And the recording is live. Hello, everyone. Welcome to the holiday Christmas version of Dallas Personal Robotics Group Builders Night Virtual. Tonight we have quite a handful of folks on the line, and we'll just do the usual and walk around the table, sharing what we've been doing or not doing the last week on robot-y stuff, related things, and what we hope to do over all that spare time over Christmas holiday. So with that, it sounds like Doug D has something that he'd like to lead us off with, and then we'll just pass the baton around and see who's got what. Carry it away, Doug.
So I was a little embarrassed with the debacle at the contest where my blog server would not finish up the video well enough. So y'all forced me to learn how to post up to YouTube. So I'm an official YouTube person. You knew me before I was famous, and you may know me before I ever get famous, but that's beside the point. But that's just a sideline to my other comment. Behind me here to the side, you probably see where I finally got around to taking Roby apart to pull his guts out, take out all the unused parts that are inside so that I can put new parts inside. And I've kind of mapped out where I'm going to put the Pi, where I'm going to put the Arduino, and opened it up so I can put in some more sensors. And that's basically all I've done so far. It's just blogging and disassembling. So with that, I'll pass the baton.
That's looking pretty good.
Okay.
At least be able to do something.
I'll volunteer next because I found something that you all might find interesting. So let me see if I can share a screen. The first thing I need to figure out. Okay, percent a window. And there.
Wow, is this the dog robot?
No, but something else dear to you all. There's Serial IO. And this talks a very good article about it. So I would recommend go look at it. Because it talks about how to speed it up and time and all that good stuff. So about the safe string library. So if y'all haven't heard about that, you might want to look at it.
So be sure and put that in the chat because I am interested in that.
I figure y'all would, because remember, I think last week or the week before, one of those, somebody had the discussion about how to speed it up and that. So let's see.
I got the link. I'll put it in.
Oh, you got it already?
Yep.
But, you know, it looks like a pretty good one. Well, in this case, he's using a GPS to run the loop and that. But it talks about, you know, the timing loops and which one's best. And, yeah. So it's a very good article, and it's pretty long, lengthy. So I would recommend going through it, as you can see. And it looks like it was well done. So I would definitely recommend reading that.
You got to put the link on the thing?
Carl did, I think.
Okay.
I just got it.
Thank you.
So yeah, as I said, it's very, as you can see, very detailed. So
looks pretty good.
Yeah, it looked very good to me. I was like, wow, I found it. So that was my big thing for this week. So
we'll go for it. That's progress.
Hey, John.
Yes.
The 3D printed robot with the 8 servos.
Yes.
Do you have a link for that?
I'll dig it up. Yeah. I haven't done much on it since, well, the other week. Whereas the nest that was put in the horns and in there. I haven't gotten to that yet. Maybe this coming week I'll get that in.
The servo horns, you mean?
Yeah.
Oh, okay.
Yeah, because that was sort of why I was working on nets somewhere around here. Yeah, somewhere around here I had the part, but yeah, that was sort of the thing I was working on nets. Okay. I'll dig up the link for it.
Okay, thank you.
In the meantime, whoever else wants to show another elf on the shelf or something.
I'll go next.
There you go, Chris.
It'll be quick. I just wanted a brief follow-up to the email trail Thanks for your response, David. There. So just to answer David's question, on the topic of update rate and why I felt the RP LiDAR at 300 RPM, which amounts to a 5 hertz update rate, isn't enough. So I just wanted to explain that with a picture here. Let me share. This is acting up. Present tab.
Yeah, when you guys were talking about the 300 hertz, you were talking about the motor RPM.
Exactly. So so 300 RPM, which amounts to an update rate of 5 hertz.
Mm-hmm.
And it is not, that's not necessarily very slow, but the reason I found it to be insufficient, first of all, I should say the context, I guess, of that statement is really, LiDAR-based navigation, so SLAM, but not necessarily literally simultaneous localization and mapping. Even if you're just doing the localization and you have a map, it comes into play. And so this is really in that context, and really sort of the context of my experience, which, again, with the complexities of RAWs, there is a very high probability that I'm not tuning all the parameters correctly, right? So I want to say that because there's just, in the navigation stack and the various parts of it, there's just so many knobs you can turn, and they're not all super well documented, right? And so there's, again, a very good chance that I'm not turning all the knobs correctly. But nonetheless, I do think the update rate plays a role, because everybody I've seen demoing something on YouTube, their robots have all been relatively slow. And, as you go slow, it does work reasonably well. So what I'm trying to show here with this picture is, right, the reason the update rate matters is because you trying to sort of match. You have a reference scan, right, at T0, and then at T1 you have the blue scan, and then you're trying to line those up, right? And based on that, you're trying to figure out, okay, if at time T0 I was at XY, where am I at time T1, right? And even the algorithms that take odometry into account, just to make it a little easier, they seem to struggle when too much time has elapsed from T0 to T1, right? And at 5 hertz, that would be 200 milliseconds, right? Between two full scans. Because at least in RAWs, it wants to look at a full scan, right? Full scan, and you look at the next full scan, 5 hertz means 200 milliseconds. And, as you go faster, there's a lot of change happening in 200 milliseconds. Now, what's compounding this is the fact that, it's not just the update rate. If it was doing a perfect clean scan, milliseconds, that would be one thing, right? Think of it as a very short exposure time, right? An instantaneous 360-degree scan. But that's not what's happening, right? Because it's kind of slowly rotating. Slowly, right? Rotating. And that's what creates a distortion that I was talking about. And so when you combine the distortion, which is not, this particular sample image doesn't show that. But when you now combine the fact that you have a lot of differences from one scan to the next scan, plus the distortion, I just have found in practice, the RAWs navigation algorithms, they just really struggle. Again, maybe I'm not tuning them right, but that's what I found. And that's why I said, well, I wish I had the RP LiDAR A3, which can do 20 hertz. And I don't know how much vibration that's going to generate on a small robot, but I feel that at that point you're getting into the range of update rate where those effects of distortion and too much change, probably are no longer an issue. But I'm not ready to spend $600 on that LiDAR. So
I would say this, Chris. You know that the NITO uses about 5. It uses about
Yeah, they're making it work somehow. Again, that's why
the RP lighter and the NITO are essentially the same. There's not very much difference. In fact, I think the RP lighter is actually has made enhancements
yeah.
to
I have
the
some NITO units that I bought on eBay for cheap, and then I have an actual official RP lighter A1. You're right. I mean, they're about the same update rate. Yeah, you can crank up the speed on the RP lighter. I'm not sure that's working properly on the NITO units, but people make it work somehow. You know, and again, like I said, it's probably a matter of a lot of good tuning of everything combined to make it work well. That I just haven't been able to get it to work well in ROS. So it's
here's what yes, we somewhere we had a link to a presentation that was made by the NITO people. The actual developers. I'll try to find that link. It was a talk that he gave at some fairly closed conference, and it was very informative. But I'm not sure. They're probably picking out specific, like, okay, if I was at point A and I was on your first scan on, say, 30 degrees, okay, and if I look at where that was at A plus T, I could see, and I mapped all of those shifts, I could probably derive something from that. And I probably wouldn't use the whole set. I probably use some subset, maybe 10 readings. So, I mean, if you look at the scans that you showed, at being a human, can you put your screen back up? The one you had before?
I don't know. Can you still see my screen?
I see something with yellow spots on it.
Okay, I switched. Oh, okay. Hang on. I guess I shared a specific tab. I didn't realize that it goes blank when I then go to something else. So hang on.
Yeah. Okay. I mean, as a human, I can tell that this robot turned to the left or turned counterclockwise. Right. I mean, as a human, I can look at these scans and I can interpret that.
Yeah, I mean, you're right. I mean, the data is there for one to interpret. Now, this is an example. Yes, there was a lot of movement or a lot of turning in between scans, but the blue scan clearly has no distortion in it, right? It's a clean scan. So that's why I'm saying it's a compounding effect. If you now imagine some distortion in the blue scan, maybe even in the red scan already, it gets harder and harder to line these up. I suppose if you allow for enough tolerances, right, in terms of how exact you expect the matching to be, you'll find a match. You just may find an erroneous match, and that's what I've sometimes seen. You can see in the visualization. ROS is very good visualization, so it's lining up the matches. And at some point, like if this hand is my map, and this is my scan, at some point it's like, oh, it's like way off. It found some lines that still line up.
Yeah.
And then it thinks it found a match, but it's just way off at some point. That's what I found in practice.
I think you have to be stationary, do a scan, race forward, do another scan, or stop. And then you get perfect scans all along.
Well,
so
I'd like to weigh in on this in a way that my experience is that a lot of this depends on how you're going to use the data. And I'd like to give 2 examples of that. The first one is, suppose the way you're going to use the data is deterministically. That is, you're going to say, all right, I can see this hallway is 20 feet long, and then there's a turn to the right. So I want to plot course where I drive forward 20 feet, and then I do a turn to the right to go through the doorway. So that's one way you could do it. Another way you could do it is stochastically, which means, okay, what I'm going to do is I'm going to drive along this wall. I have no idea how long it is. I'm going to drive along this wall until it goes away. And then when it goes away, I'm going to turn. So I have not plotted a path. And therefore, if my understanding at this particular moment in time of the environment is incorrect, it doesn't really matter. It only matters for the next, 200 milliseconds. And I'll be in a different position and I'll get a different scan at that time. So my second example is when I was early on working with sonar, one of the things I really worried about was there's two kinds of errors associated with sonar. One of them have to do with specular reflections, where the reflection goes away from you and rather than toward you. And the other one has to do with multipath reflections, where you're getting a reflection off a wall and off another wall and then back to the sonar. So something that's 3 feet away looks like it's 9 feet away because you're getting this multipath return. So I was very worried about that. And I spent a lot of time thinking, how do I handle these errant signals? They're in the middle of good data, they're suddenly bad data. And what I found out in practice was that you can effectively ignore them, because what really drives the robot are real detections, and those fake detections are transient. They come and go. So basically, they don't really have much control over the robot. In order for them to control the robot, they have to repeatedly return the data. And if they're not repeatedly, if it's just random transients, as you drive along, they don't have much effect on the control algorithm. And so you don't. So I guess the point I'm making here is that I worried a whole lot about this aberration in the data, only to find out that in point of fact, it didn't matter at all. I could just ignore it. And I wanted the same thing here. If you're trying to do deterministic programming, I want to drive ahead 20 feet, turn 90 degrees, drive 12 inches, turn 36 degrees, drive 9 inches, then clearly this wouldn't be good enough to do that. But if you just say, I just want to know what to do for the next 200 milliseconds, and then I'll take another sample, and then I'll decide to do what for the next 200 milliseconds, it seems like you have plenty of data. And so that was my observation. It depends entirely on what you're trying to do with it. That seems like from your description, what you're trying to do with it is hand it to a big pile of ROS and have ROS give you back an accurate 3D map of the environment that you're in. I have a hard time seeing how that would ever work outdoors. But even on an indoor environment, if the expectation is that you're going to get back an accurate map and that you have to have an accurate map in order to make the code work, that's a pretty tough road to hoe.
Yeah,
and that's all I have to say about that.
Yeah, it is tough to get it to work. I will say, you talked about these two, stochastic versus deterministic sort of approach. In ROS, what ends up happening is something in between. Because let's say all you're worried about is localization. Let's say I have the map, which I may have obtained by driving very slowly, through the first floor of my house, and I have the map, right? Because you're not always doing simultaneous localization and mapping, right? I mean, that's the buzzword, but you don't always do all those things at the same time. Sometimes you're given the map, and then the problem is find yourself within that map. Now, what ends up happening when you then ask ROS to sort of navigate down the hall and take a right, it looks at the map, it looks at where it thinks it is, it plots a course, kind of what you call the deterministic approach. But then every step along the way, it actually looks at, well, I think there should be a wall or there should be no obstacle. I can just go straight. But it does constantly look at, well, what am I actually encountering along the way? If you put an obstacle in its way, it'll see that and it'll drive around it. And it won't become a part of the map if you're not doing the simultaneous part of it. And so it's doing something in between, right? I mean, it's using the map, it's using its localization, and one step at a time. But yeah, certainly, I mean, the expectation seems of those algorithms is just for high quality data, in my experience, and that's hard to come by from these cheap lidars. So But
No,
yeah,
I-
it's very different from when you use individual sensors on their own, whether it's IR or sonar. You tend to take certainly a very different approach, with individual sensors compared to what ROS is doing or any kind of navigation stack. The assumptions they're making about a LiDAR scan and what sort of information is in there is just a little different, I think.
Okay.
So, Chris,
Here is the link to that Vito engineer talk link. I'm not sure. You need some sort of account to get into it. Well, darn it, didn't copy. But and I don't know, they may have taken it down by now, but this is where it was. Okay, so I don't know. You have to get over onto Adobe Connect somehow.
This kind of reminds me a little bit of some of the stuff I've been doing with the compass on the B&O 055 and the 85. In the sense that a robot has physical limitations on how fast it can move or how fast it can turn, the sensors may be sending back data that indicates that the robot has turned like 40 degrees in 30 milliseconds or something impossible. And I was getting all these spurious measurements off the B&O 55. And so what I ended up doing was just running a little queue and setting the size of the queue based on how many readings it would take in a certain number of milliseconds, basically a running average. And that running average turned out to be a pretty simple Python, method that took out all those spurious numbers. That the running average of 5 or 10 readings was still within the amount of time I needed to make a decision, but the overall effect of that was to pull out those big or small numbers that didn't make any sense. And I'm not sure if that's a common thing to do in robotics or not, but it certainly seemed to take out these weird spurious values, sort of like a Schmidt trigger, I guess.
No, actually, the problem with that is that the lag is half of the sample number. So if you were taking 10 samples, your moving average is actually 5 samples behind. And so in this case, it would be about a second behind. So there's digital filtering there's some things you can do for sure, but I think you would probably just do as David did. In Dave's case, I think he's actually keeping the number and just saying, well, the robot can't react fast enough to it, because it's already taken another sample.
Right.
If you're slow enough, though, you might just say, okay, if the number's beyond a certain value, if the differential is greater than you would expect, blow it. Just forget. You just keep the last number so that you get through that one cycle.
Yeah, understood. That would be better than a running average, even, I guess.
Well, I'm not saying there isn't a place for running averages, but I'm just saying that in this case, that probably isn't the solution.
Well,
anytime you do a filter, it introduces phase delays, and so you have to be careful about that in real-time systems. There, if you got big, powerful computers, you do infinite impulse and things like that don't do phase delays, but that's outside of real time. We can't do that in real time. So if there's a hack to get around it, I will say that I think these big spurious peaks that you're getting and trying to get rid of are some problem in the way you're reading it. I don't see those in my data. The data from the gyros is noisy, but it's just within a very narrow band of noise. It's not sudden spikes. So
I agree with you.
I think if you're getting big spikes, there's something wrong with the way you're reading the data. I don't think those should be there.
Well, I'm simply using the B&O 55 library, the Python library that's available with the Adafruit product, and
well, there you go. There you go.
Are you using I2C or are you using Serial?
I2C.
because there's issues with clock stretching on the BNO 55, and that could
Oh, yeah.
potentially be causing your issue. I had an issue with that in the Pi 2 and 3, and it seems, even though it's undocumented, it seems it's fixed with the Pi 4, that it no longer has that clock stretching issue, and I get really good solid values. But I've seen the same reading errors you have, but as of late, I haven't seen them. But they do occur with the older I2C libraries.
Yeah, I'm familiar with that, Jesse. In fact, I originally was setting I'm using a Pi 3B plus, by the way, and I was originally setting I think it's in one of the config.txt files or whatever, you set the I2C clock speed, and they were recommending knocking it down to such a speed that it was actually too slow for the robot even.
Actually, I'm running at 400 kilohertz, and I didn't have any issues.
What's the default? Do you remember?
100 kilohertz.
Oh, okay. All right.
So you can go in the configuration file for the Pi and change it to 400 kilohertz instead of 100.
So you actually increased it rather than decreased it.
Yeah, but what sensor are you actually looking at? Are you really invoking clock stretching or not?
It actually does seem to do it. I don't know why. But
does it do clock stretching?
Yeah, it does.
Otherwise, what I'm saying is, if your sensor can pull it back real fast, the problem with the Pi libraries is they set the timeout at a ridiculously low number, and that's why it doesn't work. Otherwise, the clock stretching actually times out before your thing can respond. That's why what Murray is doing was one proposed solution, because if you it's actually something like X number of clock cycles. I'd have to look it up. And by slowing the clock down, those clock cycles are longer, so it gives you time for some sensors to respond. But for a sensor that's going to take a while to respond, none of those solutions are going to work. But you can fix it, but you have to go to C. You have to do it in C.
Well, the one question that comes to mind, though, is that if, let's say, for example, because I'm not actually changing my clock cycle, my clock speed at all anymore, and if the BNO 55 fails, doesn't it just simply fail to read, or does it fail to read the right number?
Well, it'll fail to read, but the thing that you have a problem with is it can lock up the bus.
I haven't had that problem. In fact, and so like these spikes are actually spikes in the actual compass reading. Like I've got what I've been doing.
Compass, we know our thoughts on that, Murray.
I'm also in the no compass group, just to add on top of
I know. And I'm just going to explain what I'm doing here, which is that I 6 months ago was using the BNO 55, and everyone said don't do that indoors. And so what I'm actually been working on is a externally fused pair of IMUs. So I'm using a BNO 55 and an ICM 20948, which are very different sensors. And one of them I'm running, the BNO 55, I'm running as a magnetic compass. And the other one I'm running accelerator gyroscope with no magnet. And basically what I'm trying to do is find when they both agree within a certain number of degrees, and saying, okay, if this and that both agree, then I have some confidence that I'm getting a reasonable value.
Yeah, the main issue is auto calibration. If you have that turned on, it really can mess with the values from my experience.
Well, the BNO 55 is a tricky little thing. I mean, but on the other hand, when it is calibrated, it's pretty good. I mean, I get like within a few degrees of, like, I use my cell phone compass in my study, and it gets all wacky when it's around, within a certain distance of my computer or whatever. But actually out on the wood floor, it's pretty good. And then I get the robot down there in the same place that my phone is relatively accurate. And I'm pleasantly surprised in an environment like my study that the BNO 55 often is pretty good. It generally gives me a reading. Otherwise, it gives me some crazy reading. But I had spent the last few weeks trying to get a BNO 85 to work, and it keeps blowing out and basically doing stack traces and spitting bin hex over the screen. And just, I effectively gave up on it just because I was having so much difficulty getting it to give me an accurate and reliable reading. And in fact, it turns out even some of the test files that Adafruit provided would blow up as well. So I went back to the BNO55 with all the caveats that you guys have been telling me, and I still get pretty reasonable results from it.
Now, let me ask a question, Murray, or a clarification here. You said earlier when you got the BNO55 that everybody said don't use that indoors, but that's not actually what everybody said. What everybody said was, in order to use it successfully indoors, you must turn off the compass.
Right.
Just use the gyroscope. And then I actually even sent you some instructions on how to do that.
Right,
but you never actually did that. You never turned off the compass. Is that true?
I have tried both. It's got like 10 different modes, and they have a little chart that shows you which modes use a magnetometer and which don't. And I've tried both, but and this is what I'm saying today, is that I'm pleasantly surprised that even when I am using the magnetometer in one of those modes, I still get fairly reasonable results.
But my question is more specific. When you turn off the magnetometer, do you get better results?
Better results. I don't know. I'd say better. I get similar results. The magnetometer, I mean, when you don't have a magnetometer, you don't get an absolute compass reading. You get a compass reading.
But that doesn't really matter. If you want to go from one end of your house to the other, all you're saying is that it depends on what pose you initially set the robot in.
Right. But
right?
remember,
what you want is a heading that doesn't drift around. It doesn't really matter whether it's arbitrarily pointed north. You just want it to stay in place.
But that's not quite what I'm trying to do, though, is that the entire purpose of this compass is not what you guys normally use an IMU-based compass for. What I'm trying to do is, in the mode of behavior-based robotics, all I want from that compass is to know where north is. So I can say to the robot, it's sort of like those the moth and anti-moth behavior. I basically have the moth is north, and I want to be able to say to the robot, if you can determine north, go north. If you can't, don't.
I guess I'm suggesting there's an easier way to do that doesn't require you to get involved with the problems that a compass presents indoors, which is that when you set the robot down and turn it on and say go, you know the initial position. So let's just take an example that the initial position is north. Now, all you really care about after that is that it not drift around. You don't really care where it absolutely points to. Right. And so if you want to say, go to the north end of the house or go to the south end of the house, all that's required is that you know which way it was pointing when you hit reset.
Right. I guess the only thing is that to me, and this kind of gets back to some of the other challenges that the club does, is to me that's a form of cheating, is to say, I'm putting you on the floor, you now are going north, and now you should know that that's north. I want the robot to be, like I said, my purpose in this is different. I'm basically saying to the robot, if you can determine that you're going north based on these two different IMUs, if there's any sense that you can tell from the two IMUs fusion that you're going north, then head north, otherwise don't. And that's the behavior I'm trying to define. And I don't see
how that's really different than the way I'm doing it.
It's filled.
You say that you think it's cheating to have an initial direct. Okay, let's have the sonar spin around and find where you are in the room, and that way get your initial direction.
You could also use
there's a lot of ways that can. Go ahead.
You could use a compass to get the initial heading, and then turn it off, and then go to just IMU.
Yeah, that's
so you can use it to get an initial heading, sit there for 5 seconds, relatively smooth it out, whatever type of filtering, and then disable it, and then use just the angles.
That's true. I didn't thought of that, but I'm still kind of a mind that the idea with this particular behavior was to only go north when you could be ascertaining that you were going, otherwise do some other behavior.
Unfortunately, just my experience with the compass sensors they're somewhat unreliable, and there's just too much magnetic interference in houses for that to ever be truly reliable. And just the sensor and overall, even outside, due to the issues with the auto calibration and the field strengths, I just don't see it ever being, with the current sensors, being very efficient, unfortunately. I've
Okay.
tried a lot. When you do dead reckoning, it's the only thing you have to go on. So I spent a lot of time experimenting with that.
Okay, if I can add some comments on the LiDAR. So the LiDAR measurement is instantaneous because light is really fast, right? It's
Well, for one sample, yes.
yeah, that's
But
right.
this is a 360-degree spinning,
I
right?
agree.
So
Yeah.
it's rotating at a certain rate. So yeah, it's taking a sample,
That's right.
it rotates, takes another sample.
Yeah.
Well, it keeps
So,
rotating. So it's by no means instantaneous. I mean, it takes
right. Well, you
200
can
milliseconds for one revolution. So that's,
honestly,
it's not
LiDAR
that fast.
is the equipment that measures distance, right? So it can give you basically a R theta, like a coordinate with at which angle is what distance.
Yes.
So I mean, I used to work for a different type of LiDAR, like a flashing LiDAR company. The accuracy can be centimeters, can be like within a few centimeters for the accuracy.
Oh, I mean, the accuracy of those cheap LiDARs is not bad.
Yeah.
Obviously, it goes worse as you go out in distance. I mean, that's not an issue. It is definitely centimeters and even sub-centimeter as you're close by. So that's not an issue. It's just
I think these even go to like, I mean, even the flash LiDAR, which is seriously limited by the distance because it's like a diverging angle, that goes to like 20 meters. These rotating LiDAR could go to like 100 meters or something. But I mean, that's
not the cheap ones, not the cheap ones.
Oh, okay. It's diverging. Oh, okay, maybe. But yeah, my point is, if you there should be a spec, and I would think it should satisfy the spec of how accurate the position is, and how accurate is the angle measurement. Hopefully, it's
But
not
again,
too
the
bad.
LiDAR doesn't do the positioning, right? It's the software. The LiDAR just fits in the range measurements.
That's right. Yeah,
about 2,000 times a
distance.
second or 1,800 times a second, and then as you spin faster and so on. But it's the rest is the software.
Process that? I mean, instead of getting a frame of data, can you add your robot position in there? If it's stationary, it should repeat itself, right? Otherwise, something's wrong with that
Of
LiDAR.
course, if it's stationary, there is absolutely. Let me just pull the picture up so that the point that I was making is clear.
But I mean, if it's not stationary, can you add your position and rotation into that data interpretation? Think about it. It's the R theta that it can give you, and that origin is where your robot is, or where that LiDAR is.
I'm not sure if I'm sharing the right screen. You see the yellow dots?
Yeah.
Yeah, that's stationary. Okay, that's stationary. And there's a little bit of noise. These yellow dots, they're gonna wiggle around a little bit, even though the robot's stationary. These cheap LiDARs are not bad. Okay, so now as your robot's turning, this is what you get instead.
Yeah, those are not error. I mean, those are caused by your.
Well, this is caused by the robot. By the robot's
Mm.
movement, right? The laser is turning relatively slow, and at the same time the robot's turning. It's almost the same as motion blur that you get in the camera, right? I mean, you have a long exposure time, and you're moving the camera while you're taking the picture, right? That would be an analogy. It's not a perfect analogy, but it's an analogy.
But
you get this distorted view.
But you could take into account the rotational speed of the robot for error correction, I think is what he is saying.
And that's what this is. Mm-hmm. That's what the white is. So that's what I've done. And it was a lot more math than I was hoping to do. It was very tiring, to be honest. A lot of trigonometry. My God, my head was smoking. But I'm very proud of myself of actually getting it done, because I had to draw on a lot of math skills that I haven't used in a long time. So I got it to work, it just still didn't. Ultimately, I just improved the quality of the data that goes into the algorithms, but my end result, of navigation at reasonably fast speeds, it just still wasn't working that much better. So there's still a lot of knobs that I need to turn elsewhere, right? But the other thing I wanted to show you, I was talking about some ghost effects that were still lingering here, and this has some of them removed, I think. But to David, to your response there, I don't know how to show it, but it's almost like, so if the white line is the good line, meaning after cleaning this up, I get like almost like a ghost a ghost line, sort of not parallel but at an angle right next to the good line, and I could never figure out where it's coming from. I mean, I'm sure it has something to do with all the motion, of course, the motion of the robot relative to the motion of the LiDAR, which could be either in the same direction, right? Or the robot could be moving in the opposite direction. And it creates this little ghost reading, like just a short additional line that shows up. I could never figure out why it's doing that. And I decided, okay, let me just kind of throw a short piece of data away so that there's no artifact in my supposedly cleaned up data. But that's just one of those weird things where I couldn't analytically figure out what's causing this weird ghosting effect in the process. I mean, again, I'm guessing it's because if my robot's turning in the same direction as the LiDAR, at some point I've taken in a certain amount of time actually more than a 360-degree scan. Maybe that's part of it. And still, when I was looking at my math, it shouldn't really have mattered, right? But it somehow did. So that was one issue that's still there that I never could really resolve. But in the end, if you look at what it looks like without cleaning it up, clearly, the distortion is almost gone in the white line. So it's I consider that a success, but it just didn't deliver in the end on the overall navigation results. And that just, that's probably because of my insufficient RAWs navigation stack knowledge,
Yeah. Chris, it may be
Go ahead.
that as those, as you suggest, as those two bodies are rotating, so you have the LiDAR rotating, you also have the body of the robot rotating. So in a very real sense, the LiDAR is not rotating at the specified speed. It's rotating faster or slower than the specified speed, depending on whether you're rotating right or left. However, it seems like that would show up systemically, that everybody would be off, rather than just these artifacts. So
right, and I think I've taken that into account effectively with my algorithm, right? Because I'm basically looking at every individual sample, like as if it was one sample, and I say, well, at time t0, my robot was facing this direction, and I took the first sample. At time t1, my robot's facing this direction. Meanwhile, the laser has moved this way, so now I'm taking a sample that goes in that direction, right? So I'm the whole point of all the math is to take that into account, and that's why you don't get something that looks completely weird. But those ghosts, I don't know, where those came from. But
one of the reasons that made me think that was because I think I mentioned I've done a similar thing with the sonar, and it's really required because you're dealing with the speed of light. I'm dealing with the speed of sound. There's quite a bit of arcing as you rotate, but I've never seen those artifacts, and so I was trying to think what would be the difference. And one difference is that I don't have a rotating sensor.
Yeah.
Chris.
Hey, can anybody hear me?
Yes, Ron.
I'm just wondering, maybe there's some differences between the LiDAR, the low-cost LiDARs, because I don't believe they're using time of flight.
No, they're not.
No, they're not. But it's still
they're using
each
like
individual measurement each
Right.
individual measurement is, for all practical purposes, instantaneous, right? It takes a measurement and moves on to the next angle. So it's
Right.
not the individual measurement time that's so much the issue. It's just the, it takes a while to complete the 360 degree.
Sure.
I'm going to have to interrupt right here and ask Carl to cut it the hell out. We don't need baby Carl face going in, showing up
wait.
on the Snapchat.
Oh,
Oh, I'm
Whatever
sorry. I
that
got
is
the
you got
wrong
going
one.
on there is creeping me out.
No, I got the.
I like the
That's what I
robot
tried
on
to
your
do.
head.
Okay,
I like
I'll
the
shut up
robot
again.
head on your-
Sorry about that.
If it's not using time
We
of
really
flight,
want Harold
Carl,
having
I'm just goofing on you, man. I'm
I
just
need to
goofing
get
on
rid
you.
of that. Okay.
You know I'm just goofing on you.
now you made him feel self-conscious, and he won't do any more cool stuff.
these rotating LiDAR, it's not using time of flight?
No.
Wow.
It's using, I
Right.
don't know what to call it, right? The angle at which it
Parallax,
bounces
more
back.
or less, yeah.
Oh.
Yeah. So it has a linear sensor.
I don't think it matters. Again, I don't think it matters.
Triangulation.
RT LiDAR, they have one. It's called the S1. Again, that's one is in the $500-600 range. That one's using time of flight. So they're starting to have time of flight versions.
Yeah, I see.
But
Time of flight, that hardware requires, that's a lot of requirement in the hardware.
But again, even their time of flight version, I think, goes only at 10 hertz. So it takes 100 milliseconds, right, for a complete rotation. That's really the problem, in my opinion.
So Chris, when you do your dewarping, it seems to me that your robot is moving along a dimension, right? It's moving along a straight line, but the LiDAR is spinning around in a circle. And it seems to me that's correct, right?
Well, no. The picture here is that the robot standing still, spinning, turning in place.
The robot's turning in place.
And the reason I've done that is because it's kind of easier from a testing point of view, and that's kind of in a way worst case scenario. I mean, again, maybe back to Dave's point, maybe I'm worried about stuff that I shouldn't be worried about. But again, in reality, I've seen it to be a challenge. But rotation is kind of the worst case scenario, right? In terms of distortion showing up. If you just go straight, you're gonna see a little bit of weird stuff showing up in the scan. But the moment you rotate, that's when things really go out of whack. And that's why I've decided to say, okay, if I can make it work for the case of rotation, right, where I can clearly see a difference between the original scan and the dewarped scan, if I can make it work for that, well, then I can make it work for the easier scenarios. So this is why that's just standing still, I mean, in place, spinning, and I don't know if it's same direction as the LiDAR spinning or opposite direction. I honestly don't know.
But it seems to me that if you're rotating, the effect would be one of more like kind of Doppler in a way, because the rotation of the robot would either add to or take away from the rotation of the LiDAR. And it seems to me that if your robot is translating along a straight line while the LiDAR is spinning, then it would start to look like the behavior Ron and Dave are doing with these pirouettes, where you have this kind of a spiral kind of a thing because the reference point you're measuring from is changing constantly.
What if we say this? What if we just said this? Go ahead, Dave.
What if the interaction is not simply additive, that is adding in one direction and subtracting, but rather has to do with a gyroscopic coupling between the motor on the LiDAR and the robot's body? So you'd only really see it at the beginning and ending of the rotation. You'd only see it when you were accelerating and not when you're driving at a constant rate. So he's only seeing things at the extremes of his. You guys, they just busted the water main in front of my house. I have to go out there and deal with the city.
Whoops. Carl, I think, Carl, what you were talking about in terms of pirouettes, maybe there's one underlying sort of implied thing going on here that may not be obvious. In RAWs, without my additional dewarping, right? So like this picture here, that's with the artifact, the whole thing, if you were to look at that live, the whole thing wouldn't be spinning around, even though my robot's spinning around, because RAWs, does kind of have the data to some degree of accuracy, based on odometry, right? Which way my robot's facing. So it tries to keep that LiDAR scan always aligned with sort of certain world coordinates. That's why the LiDAR scan, even without dewarping, isn't gonna sort of do pirouettes and spinning around, because RAWs, knows how to deal with that. But it will slowly drift, and it does obviously have the artifacts. So maybe that's what you were thinking, Carl, when you were talking about pirouettes.
Well, I wasn't talking about pirouettes from the robot moving. I was talking about pirouettes from the like the point of view of the LiDAR, because as the robot moves and the LiDAR spins around, again, like the motion of the robot would like contribute to the change of speed, the apparent change of speed rotation wise, as the speed is clockwise approaching forward. But then if it's clockwise keeping it going forward, then it gets past normal, and now it's taking away from the forward speed. So it's like,
oh, hang on a sec. How about this? Let's think about this. If your LiDAR is reporting to you with respect to the robot, what samples it's taking, and if you're aware, let's just say that you have perfect odometry, you realize, or if you know exactly your heading, you should be able to calculate exactly where that sample is being taken, and you update, your array or whatever you're storing that information in. So in theory, it shouldn't matter, except you might experience like slow updates. Like, for example, if your LiDAR is rotating at 1 hertz and your robot's matching that, obviously you're only going to be collecting samples in the same direction. Does that make sense? In other words, if my LiDAR is firing a sample at 12 o'clock and my robot's facing 12 o'clock, that it's going to collect that one sample directly ahead of me at 12 o'clock. Now, if we rotate my robot and the LiDAR the same amount, then the next sample is going to also come at 12 o'clock, if that makes sense. In other words, we're in sync with our LiDAR at that moment. So we won't be updating the other directions. We're matching our LiDAR. Does that make sense?
I'm with you, Ron. I think there's like a
so, I mean, there you wouldn't see your updates. So as long as you appropriately, if you have good odometry as far as heading goes, and and that LiDAR is pretty good about telling you where it collected the samples, so it knows pretty much where it was pointing, then in theory, yeah, it's sort of the example, worst case scenario, where your robot's rotating in sync with the LiDAR and you're just firing the sample at the same location. And so theoretically, well, in that case, you will not see any updates on any samples anywhere else other than the one in front of you.
It's like the movie of the World War II planes where the propellers are hardly spinning.
There you go.
Because the sample rate, the frame rate of the camera is beating on the rotational rate of the blades.
Right.
Yeah, there's a modern video of a helicopter where the blades are standing still.
Yeah. Because as long as you have motion of the robot involved on the same order of magnitude, I think, as the spinning rate of the LiDAR, you're going to have these sample rate beating issues where depending on the ratio of the speeds and rotations, it's going to have different effects on whatever your algorithm is. Because fundamentally, the sample rate at 5 hertz is pretty slow, probably compared to the typical rotation or translational velocity you might have on your robot, right?
Yeah, that would be something that I can illustrate in a simulation, and I will bother to do that soon. I can show you what I've been working on, but it's at the moment I'm using an instantaneous LiDAR, that can sample every frame, but I'll slow it down to illustrate those effects.
We'll be online for another hour if you want to get to it.
The only thing I can show you right now is my interest in LiDAR is
Another hour, nothing. Hour and a half, two, maybe. I'm just saying. For my
well, maybe I
research.
could do it by then if I stop talking. But here I'll show you what I've been playing with, and this is not, at least it's LiDAR. Let's see. It'll take me a second to get it up. Wait a minute. Let's see.
So Chris, you need to buy one of these.
What's that?
It's a LiDAR, flash LiDAR.
How much does it cost?
I got on eBay really cheap, but usually they go for 800. But I managed to snag mine for 200.
Okay, I can live with 200. What field of view does it have? Like 120?
You can get them with different angles, like from like 4 degrees up to like 120, and they have different number of samples. From mine takes 16 samples at once, so you get 16 angles within that range.
Okay,
but it's instantaneous because it is flash LiDAR.
I see.
I wish I was there because I have a A3 you could borrow or an S1 you could borrow. So
okay,
then
you have like you have a lot of stuff, it seems.
Yeah, I didn't even mention this guy. This is like the high-end like a 30X. This is like that's a real LiDAR.
There are automotive applications.
You're doing this for a living or something?
No, this is my hobbies.
Oh, nice.
Being a brand ambassador has its benefits. Let's just say that.
Yeah, flash LiDAR. I think there are automotive companies trying to commercialize it.
Yeah,
I think the target price is like I mean the target is like $100 per LiDAR.
Yeah,
yeah. You at prototype with a little volume, it's expensive, but it's like 700 something. I mean that's like a few years ago now. But yeah, and those resolution is like 128 by 32, so it is an image, and you get a flash of image with depending on the optics with certain angle.
yeah, they're the flash ones right now are pretty expensive. I do think it might be the future, but the solid state LiDARs have come a long ways too. I'm really interested in the Velabit, but I can't seem to get a hold of one. So it's a MEMS LiDAR, so it has not a MEMS. It's got some type of solid state way of steering the light to get the values, and they claim it's going to cost $100, but you can't get a hold of one, even though they're supposedly released. The salespeople don't even talk to me.
It's kind of solid state but rotating.
Yeah.
Probably.
So I have something to present if you guys are amicable. So you guys have seen my rover. I have a different type of rover I've been working on. It's I'm going to share my screen here in just a second. Just booting it up. So what I have is a simulator, kind of like LFS, but it's not LFS, you'll see. So you see it?
Yep.
So this is a tank simulator. So we have 2 different tanks. On the left, the red, that's me, and on the right, the blue is my opponent. So I click start match, and now I can drive my tank around, and it's going to try to shoot me. So this is A-star pure pursuit, A-star style navigation, and what it's doing is just mirroring my position. So wherever I go, it tries to go to the same position on the other side, and if it's ain't lined up to me, it'll shoot. So the little red line shows you where you're aiming, so that's kind of a extra feature you would have for testing, but you could turn that off so you don't see that during the matches. But so what I'm really doing here is trying to simulate the real deal. So I actually, when I get done with this, I'll show you the real tanks. So in this case, I lost, red lost, and blue won. So this is all in C++, and it's modular, so I can change the courses and the tank locations and stuff like that. So I'll show you what I'm really doing. Is I'm simulating the real tanks, which I own, that I built. So I will present that window. I can't present. Oh, it needs to be a separate window. Just a second. All right. All right. You see in my screen?
Yeah.
Cool.
So
Looks cool.
here's the real tanks. This was at the Kansas City Maker Fair.
Huh. How big are those things, Jesse?
I got a couple of them. I'll show you when the video's done. But so that was actually two first students from high school that were playing with them. But I got one here, so I can actually show you what it looks like.
How about that?
So it's based off of the Polu Zumu platform. So it's just that with my 3D printed components on. And so here's the lights for telling you the status. Here's the barrel. And it's got 4 LED sensors, one on each side for detecting the hits. And they're at about the same height as the barrel for the accurate receiving. So then it uses infrared to fire and then receive. So the ultimate goal is right now you can drive around via remote control like any standard RC vehicle, but the plan is to eventually do autonomous. So I will track the tank on the field, and then I will actually have an AI or a programmed tank that will then try to defeat the opponents, which will be kids. And the idea is right now the kids fight each other, but the idea is instead of fighting each other, that they work together to beat a boss tank. The boss tank will have maybe like 2 barrels instead of 1, and it'd be a lot faster potentially than the other tanks, just to kind of even out the odds. But it's just a project I've thought about. So I've been playing with the simulator a lot. So if you guys ever want a challenge for a different type of event, that would be a fun one. It's all in C++. So if you guys want to do some other line following one day, let me know.
You know, I think that's actually kind of cool because, I mean, even in the campaign, there's a non-aggression
Right.
thing in the, you know, one robot can't beat up another robot, which I get that. But this is sort of an aggressive thing, but there's no contact in the thing, right?
Right.
Effectively,
Well,
if you run over
there
another
is some
robot,
contact. They run into each other, but
well, you can have a thing where, hey, if I got one robot running over, maybe they get disqualified or something.
Right, yeah.
But
Yeah.
because they got to be smart enough not to do that. But the rest of it is I'm shooting you with some laser beam and I'm
Right.
firing a missile at you or whatever, and I got to hold you a certain number of times. You know, like maybe something along the lines that I'm driving around, and if I can hold 20 points of damage for every millisecond, I can hold you on target.
Yeah.
Or something along those lines. I think that would be fun.
Yeah. So
So-
this how it came about because I wanted to do little arena for STEM events, and I thought battle bots was going a bit too far because like maintaining the bots and keeping them running was not going to be possible unless you had something like wedges or flip bots, but the kids are going to get bored with those real quick. So instead I went this tank route, and I've been doing most of my work lately on the simulator to get it to the point where I can start to try to some ideas for implementation of a AI or opponent.
So you're creating your own simulator. I had to step out for a second. I think you were showing it,
Yeah.
right? So that's
Yeah.
that's your simulator. Have
Yeah.
you looked at off-the-shelf simulators at all? Looks like a lot of people like to create their own simulators. I'm the only one promoting the use of off-the-shelf stuff.
Well, but
I
the commercial ones are so slow.
I do real-time simulation work for my job, so a real-time simulator for me is not too far off of my real job, so I'm staying in the same little circle. I've looked at ROS, and the problem I have with ROS is, like with Gazebo, is that I'd have to do a lot of work just to get it set up, and it's actually less time for me to do this than it would be to do that. But ROS has a lot of plugin modules that would be very interesting for me to use. But when I start looking into ROS and all the different processes I have to running and all the inter-process communication and everything, I've just, for the time being, it's just easier for me to do something simpler. And I've always been trying to have, eventually what I like to do is be able to plug the tank into the simulator and have the intelligence for the tank actually be on the tank itself. So I could do what they call a hardware in the loop or software in the loop testing with the tank code. But I'm not there right now. All the intelligence right now will be on the desktop, which is doing the tracking for the games and everything.
Well, Jesse,
I'm not a fan of Gazebo either.
Yeah.
But I did a presentation maybe a month ago, when one of the Saturdays. You should find it on the YouTube channel. My favorite is Copelia Sim. Used to be called VRAP. I don't know if you know about it.
I've heard
You'll
of
find it in the YouTube video. Another good option, I think, that I just don't have a lot of experience with, would be VBots, which became open source last year. Probably faster than Copelia Sim. But Copelia Sim I found really easy to use. I mean, it doesn't depend on RAWs or anything else. It's relatively straightforward to put your robot and environment together, and then you write your controller logic, and you can get it all set up so that you have the same code running the real robot that's controlling the simulated robot. So that's all doable. So take a look at that video in Copelia Sim. I think it's a good choice.
You can find the video.
I've heard of it.
Jesse, you can find that video on the website or on our YouTube channel. So
let's see what I come up with in the next.
Jesse, thanks for the concept of the tank. One of the things we're dealing with down here in New Zealand is that and I've been trying to set up a robot club here, and of course, once we've got a vaccine, it's more realistic to actually think about that. But one of the issues I had was that it takes weeks for us to get parts down here. And if I was to set up a robot club for kids, every time they had a contest, they'd break their robot and it would be weeks before they get back. So I really like this idea of having the non-contact tank robots, because the little Polu robots are within the budgets of people here. They're, we basically pay about 20 or 30% more on the dollar than $1,000. But it's a great idea because it means that we could have kids competing with each other without breaking their robots every time they get together. Really
exactly. I've thought about either selling my tanks as a kit, or maybe doing like events, like lease them out to birthday parties and that, where kids could set up the arena and let the kids drive them while I'm just watching and sell the time instead. I've been taken to STEM events, so I've calculated I've put about 40 hours total time on the tanks. I haven't had to modify the code once. I haven't encountered any bugs. I've had 2 failures in the whole time, and all it was a screw came loose, and I had to put the screw back on in those 40 hours. So I would say they've been working pretty well.
Well, I think that you could, for a club down here, the only thing that I think that would be necessary, there's the aesthetics of the plastic tank look, but even just to say, forget that part of it, all we would need would be a small board on the top that had 4 sensors or 4 or more sensors, and then the tank turret basically being your IR source. And as long as all of the robots competing had the same one of those, then it just came down to programming, which is, I guess, the whole point.
The one warning I'll give you: the barrel is not cosmetic on my tank. If you use a standard IR emitter, they're so broad, because your TV remote works no matter where you're pointing at, that it works too well. I was also having issues with infrared even going through the plastic when I had a plastic barrel. So I'd have the tanks side by side and they were still hitting each other.
So you just have a tube?
So I have a metal aluminum tube, but I also went to a fine angle IR sensor. So it's like a 9-degree IR sensor instead of a broad IR sensor. And the other thing I did is I really reduced the brightness. So I reduced the amount of current I was putting through it, because I was having issues with it bouncing off walls and still picking up hits.
Right,
So
right.
tuning that IR power is really one of the keys if you do decide to try it, because you'll have a lot of issues if you don't really crank down on that IR power. Even at where I'm at now, they'll hit each other from 30 feet away still. Even in sunlight, they still work. So,
and I can just imagine some 9-year-old kid cranking up his IR power so he can blow the heck out of his competition.
Pretty much, you could hit everything in the whole arena with one shot. So,
Jesse, are you doing are you just doing the on-off, or are you doing a modulated coded thing so it knows from which
I'm
cannon?
setting sharp IR codes.
Sharp IR.
So I can actually have multiple tanks and even have teams, and each team would have a unique ID. And also with reflections, you don't shoot yourself as well, because that happens as well. So I put quite a bit of effort into it, and you just use the Arduino IR libraries for it, so I can send and receive. The only trick there is support 4 IR sensors at the same time versus 1. So there's some modified code to make the 4 of them work, because it works via interrupts. So when you start having 4 of them, then it starts to get a little more messy, but it works.
That's cool.
On GitHub or anything?
No, this is just all, like I said, I have to decide if I want to take it commercial or if I'm going to open source it or what. I've been in talks with a company, aka brand ambassador company, Spark Fun, about potentially carrying it, but nothing's come of it yet. But maybe someday I'll have a kit available, and then it'll be open source with the board and everything available. But until I make
that Kickstarter, Indiegogo, you know, that might, although when I say that like, oh, that's a simple thing to do. It is so not simple, and it is a lot of work, but you know, but it is an avenue, right?
My friend Michael did that for a product you guys have all heard of called the OpenMV camera. He was involved with that Kickstarter, and he said he would never do a Kickstarter again. That's how bad it was. When you take into account the taxes, all the other aspects of dealing with the customers, it's really a difficult road to go down.
No doubt about that. No doubt.
So since I have a inside connection at Spark Fun, I think that's probably, if they're interested, I think a much more efficient route.
Oh, speaking of that, Spark Fun, I just got some email that on the 23rd, starting at 10 Mountain Time, they're having their dumpster dive.
Yep.
Get a pound full of junk for $20. You don't get to pick what it is, and you just get $20 worth of. It's a pound full of stuff. No telling what it is.
Now they actually they go a little effort. They go through a lot of effort than just giving you junk, though. They actually do try to give you some functional boards and stuff like that in there. In the old days,
Harold?
they did. Yeah.
Yes, sir.
Harold, did you just light something on fire?
No.
There was smoke. There was smoke while you were out of the scene.
Oh, that was probably steam coming off the ground beef and ground pork that I just poured out of the thing into the. Here's what I got to do to make the meat pies. I've already browned the pork and the beef. I got to dump that off, and that's what you're seeing the smoke coming out of. Now I've got to dump a bunch of butter in the pan with some EVOO and do the garlic and the green pepper and the bell pepper and the onions. And I'm about to make the wife really friggin' hungry, even though she just ate here in just a minute.
As long as it's not a robot flambeau, which is what I thought we were doing.
No. I'm in the kitchen today getting ready for Christmas Eve dinner with the family.
David, I thought you might be looking for a place where you could redirect the water main break to put out the fire at Daryl's place.
Is that dumpster dive? Is that something really good?
For what you pay for, the last one I got, which was not cherry picked, I made sure they send me a standard one and not a special one. I would say there's about $120 worth of stuff in mine. Yeah, and it was basically products that they don't have enough of really to sell, or something that they tried that didn't work out, etc. But a lot of those things are real products. You're going to get some stuff which maybe work, but most of the time, a lot of the stuff they give out is good stuff. So they're
Yeah,
not
I fully
just
sus-
throwing a pound of junk in there and sending them
No,
out.
I don't think it's trash they give you. I think it's
No.
probably new products they can't sell or won't sell any more of, and so they're looking to give them to somebody like I give to people things that I know they're going to use these because I can't use them, and I'm at least that's my impression of what I see out of that.
Yeah,
Well, I just want to follow on
I've got a whole
Jesse.
shop full of stuff like that. If I could get $20 a bag, I'd be in business.
If you had a nickel, Doug. If you had a nickel,
At
Dave,
metal development kit from 1995, that kind of stuff.
Jesse, I just wanted to follow up before we get off the subject.
Yeah.
Is that I highly look forward to your product becoming a kit or whatever that people can buy. Because from the standpoint of a club, having like if everybody has one of these little Polo Zumo robots, the idea of not everybody building their own and not everybody having the ability to crank up the IR voltage and all that. If there was a standard plug-in for a Zumo that allowed for these tanks, I think it would be great.
Well, I appreciate the feedback. I'm in the group, so if you want to email me, we can always discuss this offline as well. But I'll get a hold of Nate again and just see what he thinks, because last time he was interested. The main issue is price. I'm using all separate breakout boards, and so when you add up the cost of all my breakout boards, I'm looking at with the tank and the motors and everything, my kit cost was like $150 to $200 a tank. And I have 4 of the tanks now, so you can start doing the math. It adds up pretty quick. So I'm hoping to get that down to under 100.
But what if you just had, without the aesthetics of the tank and all that, just that plug-in board with the IR on it? That wouldn't be
right.
more.
Well, the thing is, there's a TNC on there. There's a motor driver. There's a low voltage regulator. There's a soft switch. There's all kinds of other stuff going on there. It's not simply 4 IRs and 4 one emitter. So it's a little bit more complicated than that. And
so
it's a board I designed.
So you're only using the Zumo chassis. You're actually not using the controller. No. I see. Okay, gotcha.
No, so it's a completely standalone board with everything needed to drive. When you start adding up the cost, it doesn't make sense to add a Zumo control board on top of that. So, but I hope to reduce that cost and hopefully get everything on one board without the separate breakout boards, and then really spec out the price and see if I can get it down. What would you think would be a reasonable cost for?
Well, I mean, as I said, I'm in a bit of a unique situation from you guys because American prices are American. I mean, I used to live in the States, and coming down here, there's the shipping charge, and then there's the New Zealand dollar. And like I set up one of our neighbors' kids with an AlphaBot 2, and by the time we got the batteries and the charger and the robot, it was like $250 New Zealand, which is like about 200 US, and that's quite a lot for a family here. And so, I mean, you can go to xe.com and see what the current exchange rate is, but from my perspective, I've been trying to keep it around 150 New Zealand. 200, but by the point you get to 200, 250, you start knocking a lot of kids out.
Yeah. I was thinking these might be things more that the clubs might have that they could lend out to children rather than necessarily the children have it themselves.
Yeah.
Like I said, I've got 40 hours on mine and I haven't had any issues with robust issues on them. The only time I broke anything was a kid stepped on one. So I learned my lesson. Do not let the kids drive the tanks on the ground. That will never happen again.
Yeah.
Sasquatch will push one, huh?
Yep. Well, I look forward to see what you come up with.
Sure. Thank you, guys.
Hey, Jesse. The linear actuator that you talked about last time, did you say it was 50 pounds and 1 inch per second?
It was like 50 pounds and 1 inch per second. Yeah, 30 to 50.
Where did you get that?
It's just available one of the ones at Polu or Robot Shop. Let me look. I'll send you a link.
Okay, great.
In the chat.
Yeah.
Jesse, I have one idea about a game though that might. This is kind of like building on what Harold said. You know, you could have the two robots perform some task. Okay, maybe it's push a block to the one end of the arena to the other, but if they get hit with the laser beam, their motor stops. Okay, and so there's sort of a, you know, well, in gaming terms, there's sort of a PvE and a PvP going on at the same time. So something to think, that might be a possible contest idea.
Yeah. I've got like 7 different plans for how different types of events. So
can that aiming be indicated with the laser spot instead of? I mean, infrared is the sensor, but can you visualize that aiming with a visible laser?
Right. I've thought about that. The problem I had is to find an actual eye-safe laser. I was looking at infrared lasers first, and I looked at all of them, and I realized kids were going to get blinded if I used them. So I went to IR LEDs. And even then, the one I have is so bright that at full power, it's just ridiculously bright, because instead of a spread beam, it's all like in 9 degrees. So like, it really is intense. So it's not
infrared is also high energy. I mean, infrared can burn retina too. That's
okay. I sent
infrared. You need to.
I added a link for the actuator.
On the benchmarking side for this idea, do you remember that? I think it was done by a CMU grad, and it went pretty far for a while, but then it seems to have petered. But you remember the Anki drive? So there was a basically, and I just put a link for some review. I don't know if it's a good review or not, but they had these. It was a fairly simple course you'd lay out on the ground, and it was basically a big loop, like a NASCAR loop or something, except it was all flat. And then these little cars, tiny little, like larger than slot car size, maybe the size of your robots, or a little smaller. But these things were fast, and they were smart enough to be able to know where they were on the track and where they were relative to other cars. And they could drive themselves around, but they also had the ability to do battle with each other. They would use, like, if I remember right, you would, like, you could have your manual one fighting an autonomous one. And
yeah, that was all done in the software. There was basically, it was done. They know their position on track using some really clever techniques. The board itself is where the positioning is, and then the car is able to read it on the board. It's really clever, and they actually, if you look into it, there is a way to hack them and write your own code for them. So it's quite interesting. Anki as a company kind of went down to closing down. I don't know what the status is, if you can actually use the hardware and software right now or not. But
yeah, I remember they shut down, but for a while they were really strong.
Yes.
And I was just thinking that as you consider commercializing your idea, there might be some lessons in their benchmark to learn from and avoid the bad parts.
Yeah. I don't think I'm ever going to create like a kid, like generic toy for their being target. It's always going to be associated with STEM, etc. I don't quite want to get into the toy market.
Yeah. Fair enough.
Oh, I can show a few things I've been working on. I won't suck up much time. I always say that. What's that?
Go for it.
Okay, let me try to present here.
I meant to hit my microphone button. I hit the hang up button instead.
Sorry, welcome back.
Ooh.
Oh, there's a picture of Jupiter and Saturn. That's the best I could do. Unfortunately, I don't have a mirrorless camera on my telescope, so it shakes when it takes a picture. But that's, I should have superimposed the moon in there, but that was out on the horizon last night.
Yeah.
You know, just
Oh,
about.
that's impressive. Which camera were you using to get that?
Just a Canon, just a cheapie that I got off eBay, but I was using a C8, 8-inch reflector telescope.
Oh yeah, okay.
Celestron,
Hey,
yeah. So I had a big lens.
You have
on.
a C8?
Huh?
You have a C8?
Yeah, from way back, polar mount, you know, ancient.
Yeah, I do too.
But
you're right. You need to hire a couple of strong men to help you carry it.
yeah. But let's see, I'll fire up this thing that I've been playing with. Okay, so yeah, this is a I'm working on combining physics with a LiDAR. So I've got you can see sort of a LiDAR. I'll load a course pattern here. Wait a minute, let me get, so you can see as we move the robot around. And what I'm going for is speed so that, you know, the thing can run in real time, but also accelerated time. So I'll just show you a real simplistic, I think it's when I get near a wall, I'm turning 100 degrees. And the cool thing here is I can come in here and I can, you know, in real time, I can alter, let's see, you know, I can move walls around and stuff like that. Or I could delete walls. Let's see. So anyway, it's running at, looks like what, about 100x. And I can slow it down. But anyway.
Okay. Just so I don't scare David, I have smoke billowing from the onions, bell pepper, garlic, and butter thing that I'm getting ready here, just so that I'm just letting people know so they do not get alarmed.
Okay.
Yeah, but for the rest of us sitting here who haven't had dinner, that is borders on cruel and unusual.
He's just trying to make our tongues water.
Hey, when we can get back together at some point, let's schedule some stuff, and I'll be happy to make this same meat pies for everybody in the club.
Cool.
I take you up on that. I may even remind you.
Please do. Please do.
So, hey, Ron, go back to your simulator there.
Okay. Let's see. Hang on. Let me stop this one.
Yeah, when I looked at that image with
So you got a course on there, and is the white arrow represent the direction the robot's running in?
Yeah, that's the robot's heading.
Okay.
Exactly. Oh, here, I'll slow it down a bit. Hang on, let me go in and let's slow it down to like 2x. So the dim lines are the lines that represent you know, beyond range. It's not registering a hit. And so it's a very dumb algorithm. I'm turning like 100 degrees at the moment. So I have a real simple controller here. Let's turn 45 degrees. That's when
your scans happening instantaneously, or you know, is
there
going to be simulated distortion?
Yeah, that's something I'll add, which is a variable anywhere from, we'll say, just to humor the what is the 1 hertz to the typical that I have on my LiDAR is about 5 hertz, I think. So I'll definitely build that into the simulation, and also maybe the idea of course, as the LiDAR scans appropriately, if the robot heading is known, then appropriately, you know, compensating for the robot direction. But I think if I do that, it'll make it very apparent some of the different artifacts you might experience with a slow scan LiDAR. So, and in this sample right now, this is pretty simplistic. My main goal here was, you know, to have a little wall editor, you know, that somebody could go in and create like, you know, you can generate new walls and so forth, or move walls around. And the idea is I wanted, well, one, to be able to handle like the soccer course, you know, create other possible things like firefighting, or even like room or house scale type stuff. But I thought, again, kind of something that would parallel things we do in the club. And so what I'm in the process of integrating right now is this simulation and including 3D. I mean, 3D isn't needed for this, but I just figured it's kind of cool, you know, to have the ability to, you know, to experience the 3D effect, and it makes it neater for presentation, that sort of thing. But the other thing I'm working on, go ahead.
Ron, just following up on Jesse's comment, you know, Mark Sims tells me that a good guess is that light travels about 11 inches per nanosecond.
Yeah.
So if you want to fold that into your model, that would be more realistic.
I'll consider that part instantaneous, but the sweep speed of the LiDAR is definitely something of interest.
Well, I have a question, if I can. I've never used LiDAR myself. I've used something like it made of just the sharp IR parallax detectors. But the reason that I've always been a little nervous about it is because you only get this one plane. You get this one line. So if you're running around in a simulation like the one you've made here, where you have walls that are the same and go all the way down to the floor, that's okay. If you're running around the house where you had, for example, a rocking chair, and you come up behind that rocking chair, you have this leg sticking up in the air, the back of the rocking sticking up in the air.
Right.
And that LiDAR is likely to not see it at all. So you can't actually use it for any, maybe you can use it for for path planning, but I don't see how you could use it for any kind of robust obstacle detection or anything like that, because it's just this one line. And
Sure.
what you're run into is almost certainly above or below that line. So how do you deal with that?
Well, that's a good question, and maybe that's where we could augment the simulation. I was using that just primarily for following, you know, wall contours and or things that are going to block your view. For example, so the next thing I'm working on is, you know, physical simulation cans, you know, boxes and crap, some movable, some not. Anyway, so there, of course, the LiDAR will be obscured by these obstacles, assuming that the LiDAR, you know, depending on what level the LiDAR is sitting at. And I guess one of the typical scenarios with the can contest, well, I guess people have done it different ways. I guess some folks have put their LiDAR above the cans and used other sensors to detect cans. So that's sort of a possibility, or maybe since the LiDARs are fairly inexpensive, maybe multiple LiDAR, maybe some of these other types of LiDAR sensors, that sort of thing, or
What
maybe
about,
even sonar, you know,
What
things.
about something like a real sense?
Okay, I don't even
Well,
know what a real sense is.
That's what Chris was just suggesting in the chat, that you solve that problem by adding other sensors like a sonar. And I guess what that means, my confusion would be, well, if the sonar is doing all that, why do you need the LiDAR at all? And I think from Chris's earlier description, if you'll pardon me, that you need it if you're going to go down the Ralph rabbit hole. But I'm not sure that you need it for any other reason. So that's why I'm asking. In the case of your simulation, that's a nice, pristine, beautiful environment. It's why I always object to nice, pristine, beautiful environments for robot contests, because it ain't like the world.
Well,
And,
yeah, I do give that some
so that's
thought, because I have been working with a real LiDAR, and so the environment's not going to be that pristine. It can be, and I do like the idea of having that capability. But the other thing is, you know, certainly there can be trash in the environment. Like my typical, like my office right now, I have a few clean walls and I have cords and things that make a mess out of the LiDAR. And so that, you know, that maybe that would be a possibility for simulation. My goal right now is I just want to create this thing, and we'll see if it's something that anybody has any interest in. I'm not going to invest the kind of effort I invested in LFS. The documentation alone probably took me a month to write. So what I'm going for now is just something that I feel like might be a useful tool, and I believe I could create a very simple interface where it's not, you know, atrocious thing to deal with. But my goal is, I really like the idea of being able to run a simulation faster than real time, and much faster. So I've abandoned 3D physics for 2D physics, but yet, you know, I will have what we're seeing here. I'll have it rendered in 3 dimensions, and, you know, whether I make can behavior, which is right now 2-dimensional, But my thought with soda cans is I kind of like the idea of a simulation that would have real collisions and maybe would model what happens if you strike a can, or try to drive it at a high velocity. At the moment, I would do a very simplistic transition from a vertical can to probably a horizontal rolling can kind of thing. But anyway, it's just a little playpen right now. But my goal is, go ahead.
If I might, one of the things I've noticed about David in the time I've been with the club is that most of his questions have a meta level of philosophical inquiry. And
I have a word for Dave on this. Nito does it. They use a LiDAR to map not only the room it's in, but when it's finished with that room, it goes to the next room. Does that one. And when it gets to where it can't find another path, it goes all the way back to the original starting station room. And then it uses other techniques to find the starting station, but it does that. And so there's a case where they're doing mapping in a location. They're sensing, and like Jesse said, in their case, they're using two major strategies that I can think of to get around the problem of the rocking chair. One is a nice clean body without any sticky corners or anything. And the second one is they have backup sensors. And in their case, they have drop sensors, they have bumpers, and probably some other stuff too. But those are the two that I can think of that they use for navigation. So, I mean, it's possible, David, that's what I'm saying.
But it kind of gets back to what I was going to allude to, which is that we're kind of talking about different things that it even goes back to like Rodney Brooks and the MIT environments, that these are very controlled robot environments. And for contests, I think that's entirely fine. In simulators, it's entirely fine. You say the walls are going to be this color or size and all that, and you define that environment. But I think that one of the things I share with David is that I'm not interested in a controlled environment. I'm interested in getting my robot to be able to run around in my house, which also has lots of things like cats and things like that that have to be negotiated.
I'll put some cats in the environment. Do you want cats?
And there's also just to finish that idea, there's controlled environments, there's uncontrolled indoors environments, and then there's outdoor environments. And I think it's good to keep those clear, that if you're designing a robot for one of those environments, fine. You don't need bumpers if you don't have anything hazardous, but if you've got things like cats and rocking chairs, you need to deal with that. And so maybe it's good to kind of clarify the conversations we're having about what the target.
I'm not talking specifically to what David was talking about. I'm talking about in a real live house with real life stuff.
Cords and shit.
Cords, the whole ball of wax. And you know what? Anita's not perfect, but like I say, they use their two level strategy. One, the robot has a very slick, round, not going to hang up on anything by itself. And then it has the LiDAR that's mapping the room. And if the LiDAR fails because of it not being in the plane, it has its bumpers as backup.
Right.
Now, if we were building a robot, we would probably use the 3 strategy. You'd have the LiDAR, and then you'd probably have some sort of IR sensor, and then you would have the bumper. But it's all, I mean, I don't think you should rule LiDAR sensors out because they're in a plane.
But I do have a question about, and everybody in this group has heard me pet peeve on this for years, so just roll their eyes. But it's one of the problems I have with robot contests in general. The argument always made is, well, we're going to take baby steps toward our general purpose robot that can exist in the real world. That sounds like a good argument. So we'll have this simplified environment where we learn simplified things, and that will lead us toward a real world robot. But I have not found in my 30 years in DPRG that that's actually what happens. What actually happens is that what that leads you toward is robots that are more and more specialized for that particular contest, until you end up with a robot that can't do anything if you don't have the contest course. It doesn't lead us to general purpose robots, it leads us away from.
We need to talk about what a person considers a general purpose robot. To me,
Well, one that you turn
a
loose in
general
the
purpose robot is a robot that could be reconfigured quickly. So, if you wanted to do an environment, and, and we have had contests where robots could roam around the room. And, it's a pretty big challenge for somebody who's just starting off. And I do think
I don't disagree, but I would use an analogy. When the boys were little, we used to go skiing a lot. And so I'm up at the top of the slope, and I have an idea. I don't really know what this slope looks like. I don't have a map. I didn't get a predetermined map. But I have kind of an idea of the route I'm going to take down the mountain. But as soon as I start going, all that goes out the window. Every turn changes my trajectory until what I end up with is a path that is nothing like the one that I had envisioned when I started. Now, I'm a human with a big brain and good sensors and all that, and I understand I'm going to do that better than a robot would do the same thing. But that's when I was talking earlier about the difference between a deterministic approach, and I don't think a deterministic approach is that fruitful for us in the long run. And it seems like that's what all these robot contests are aimed at. Look, Doug's actually rolling his eyes. Didn't I predict it?
No, what I'm just saying is, that I would think that the robots that we use in most of our contests are more like state machines type robots. So yes, they are dedicated to a specific, if you want to call it a contest, but they're more of a state machine type robot. And I think there's a lot of room for a state machine type robot, where I think in what you're talking about, a deterministic robot, they could actually have trouble in some of the cases where the state machine would not have trouble. I mean, there are different purposes for what you want to do. If you want the robot to freely roam around, then that's, you can do that. And this, I mean, what is the very simple thing? You can have a bumper on it, like these little object avoidance ones. They hit a bumper, they turn around, where they have a sonar and they turn around and they just wander around. They don't have any path they're going to. They don't care where they are. They're, that's not exactly what. If you're gonna,
as you know, Doug, I do navigation non-deterministically. All I need is an endpoint. I don't have a path, and the robot itself will find its way to the endpoint. So I don't think that that's necessarily a cut and dried matter between the two. I do think, though, that, I run my robots a lot, and I watch them a lot. And I watch them in my environment, and I take them over to a friend's house and run them over there and see, it can raise up on this side and get high centered here and get stuck and can't get loose. How can I solve that problem? You're never going to solve those problems if you don't run into them. So if you always run on pristine, clean robot space, you're never going to solve the problems that are going to be needed in the real world. And you're going to.
I would argue that most of us are struggling to solve the controlled environment problems. We're struggling to do those. So I agree. I've seen the improvements that you've made, even on your outdoor robot, over time. Like the way your stuff goes up and down, as the robot goes up and down. There's a lot of improvements that you've made over time where you've really polished that apple. And you're right. You probably would not have done that if you had not learned from your previous state. Where you had the robot at a certain state, it failed. And then you learned, okay, why did it fail? And then you fix that. And then, now it works better and after a while, you beat down all the major problems. And then you run into the problem that happens once in a purple moon. You know what I mean? Otherwise, a robot would not normally ever run into this, but you've seen it. And you have to decide, do I really want to fix that or not? I don't know. Maybe you do. It depends. But I'm saying, I think that the club's contests progress you through a certain learning stage. Now, if you don't know those things, then you got to overcome that and learn it. And then when you get to a certain point, then you can kind of be where you are, where you're building and fine tuning. But, let's say let everybody run 6 cans. That's one. That usually takes a camera. It usually takes pretty good navigation skills. It can use the walls, but how many people can honestly say they can sit here and their robot can do that? And I know you can, Dave, because I've seen it. But you know what I'm saying? There's a lot of people who are still building that robot.
Maybe I'll talk to David outside of this meeting, and I'll find out just how trashy I need to make a simulated environment to appease.
Well, hey, Ron, I took a RP LiDAR into the 6 can course and set it in the center and in a corner and at the starting position. And I posted those. If you go back, I'd have to find the link. It's in YouTube, or it's in our meeting. You go back in our history.
I've done the same. I've got a whatever Nito, whatever it is.
Yeah,
I've done the same thing.
Is, in the center, everything is hunky dory.
Right.
But when you put it in a corner, it's just like sonar. There is a point where the light doesn't come back.
Right.
It just goes off, and so it's not. So as far as the sonars, the LiDAR is concerned, that reading is a bad reading because it never got a return signal.
I noticed the sharp IR detectors that I used, when they point into a highly reflective surface, they don't work. And so, you can't use that to measure the distance to a window pane or to a mirror. In the building that I work in, there are these, the doors all have these metal kick panels on the bottom, and they're, real pretty polished chrome. And when the robot sees that, he says, hey, wide open space here. And so then it turns toward that reflective chrome. And as soon as it does that, its front-looking sensors see it and say, oh, no, don't go this way, turn away. And it turns away, and the sharp IR says, no, there's plenty of space. That's 15 feet that direction, So in that case, what saves it is that it's an angle of incidence problem, and as soon as you get off that angle, that weird reflection goes away. But I imagine the same is true with LiDAR as well, that it doesn't work on a reflective surface.
Yeah, but I think what I was trying to get for Ron is you can't have your simulated LiDAR returning 360-degree readings, because some of those readings is not going to return.
Oh, well, without a question. I mean, I'll invest some effort.
So you need spaces along your simulation that have mirrored walls.
Okay.
And you need places where there's sunlight that wipes out, coming into a window that totally wipes out the signal. It's not just Gaussian noise. It's not just a noisy signal. It's specific errors that happen. And then I would also like to see cats with laser beams.
That's what I was going to suggest. I think a moving cat, you have to choose the color of the cat being black or white, and it moves around, and and as mine does, it plops right in front of the robot.
Oh, black? You're going to limit it to just black and white cats? What about tabbies?
Choose the color. Randomly colored cats.
With fangs.
Yeah.
Calico cat.
Yeah.
I got something I'd like to share.
All righty.
Anybody remember this? The RAD-2?
Yep.
Anybody remember the RAD-2? It was supposed to be the Butler bot. Well, the big problem, it was all RC driven. And what happens is the RC controllers quickly broke or got lost. And so these are showing up they show up periodically, not every day, but periodically. And they have a lot of cool, so the guy, it has a voice that, says things like, I don't know. It just says kind of cool retro robot-y stuff. And I found out this is what it looks like when it's all tore apart. You saw how fast I did that. They have a board here, and on the board, it turns out that the controller was based around a PIC chip, and you can actually, by grounding certain pins, you can actually cause it to cue off one of the voice signals. So my idea is I want to take this guy and modernize him a little bit, but not lose all that retro voice and stuff. So anyway, that's kind of an interesting little project. We'll see how it goes.
Doug, where did you
Oh,
go?
did you notice the three Nerf gun, the three dot Nerf gun in the front? Did you notice that?
No.
Well, that's just an added feature. See it? Anyway.
So where did you go dumpster diving to get that?
Those I picked one of them up. These aren't new. This is a case of COVID gone wild, and I'm sitting here, bored out of my gazonkos, and so I pulled up an old project that I had, and this is it. Let's see how it goes. And I played around with one of the things I was concerned about. The original one used, I think, a NiCad battery pack. It was like 6 volts. And I looked at, it has a very simple regular voltage regulator. It's just basically a resistor and a Zener diode. So by changing the resistor out so that I don't fry the Zener, I was able to put in a NiCad, lithium 2-cell, whatever, battery in it. And so anyway, just have to be careful with it. But I got a spare in case I squirrel it. So we'll see how it goes. Just something to play with.
And I've got something for David here. Does anybody know who this is?
No.
Oh boy. Rocks, the freeze bot from Logan's Run. I'm just guessing.
Yeah,
I think that might be right.
My thought there is how about instead of a cat, how about a mirrored man?
There you
Looking
go.
for sanctuary.
A mirrored
Looking for
robot.
sanctuary.
Forget
You may
the
remember, Jesse, the closest we've gotten to a head-to-head contest was we have this contest where you have to go out and collect 6 orange-colored soda cans and return them to the recycle bin. And then Doug suggested some time ago that we do that with 2 robots head-to-head, starting at opposite ends of the course. And then whoever could collect the most, actually whoever gets 4 cans first. And a lot of times they knocked them over, so it's whoever got any can. But that was the only time we actually ever went head-to-head. I don't think that contest has been held in a few years. But I know that Doug had to come up with all kinds of rules about how you couldn't interfere with the other robot. And since almost everybody uses the camera, to recognize the can. But my robot didn't use a camera to recognize the can, so I got one of those million candle power flashlights and had it, and I could use that. I could blind the cameras on everybody else's robot. That was allowed within the rules, although you know how that works. Once you do it, it goes into the rules.
Yeah, that's right.
But most of the rest of our contests have always been basically some task that you have to accomplish. Now, we did do mini sumo for years, and that was very popular, especially with the kids. There'd be 50 kids gathered around that table all screaming and shouting. But for the most part, I don't know any other contests that are head-to-head. Doug, is that true?
Well, no, not head-to-head, no. But there's well, you mentioned Mini Sumo, so Seattle Society of Robots is having their first virtual contest, and it's a little different. You remember Donna? She visited for a while. What they're doing is you mail her your robot, and she's going to run them essentially to their standard rules, and her garage, I think, and then it'll all be live on some sort of Microsoft tool. I can't. It's not Google Talk, but it's whatever Microsoft does that's similar. And that's on the 16th. And I believe your robot has to be in her hand if you're by the 12th, I think. I'll put the link down. I got it here.
Well, that would actually work perfectly, or it seems like it would work perfectly with what Jesse was proposing, because you could send the robots out and have people code them, and then you send them all in to run the contest. You don't have to be there.
Yeah. Well, you can imagine, in a perfect world where everybody is nice to each other, and but you can see, like, she puts in the battery wrong or something, and your robot just sits there and dies, and so you lose. And your robot was at least would run, and so you get mad at her. I mean, there's a lot of potential when you open it up like that. There's a lot. What if she mails your robot back, and all you get is when you come, when it comes back? I mean, how are you going to feel about that? So there's a lot of potential downfalls to that. We brought this up when we were talking to her about it, but that's the way they decided to go. I know that everybody's struggling to figure out how to, because we all enjoy good competition. That's why you need to keep Ron going. Where's Ron? Ron, are you programming, boy? But we're sooner or later, hopefully, when everybody gets vaccinated, we can have a real competition. But it would be interesting to see, well, how do we handle, let's say, the Murrays and the Jessies and the Chris's at that point? How do we allow them to participate in it in a way that they, they're always welcome. We can put them up. If you guys show up, I'll put you up in my spare bedroom. But I'm just saying.
I don't know, Doug. I think I'm getting addicted to this life, so I don't think they have anything to worry about. I think I'll side with them. I'm not sure I ever want to go back and see any of you face to face.
Oh, Ron.
Yeah, I do hope
besides not getting COVID, I noticed I haven't had a cold. The last time I had a cold was when I went to the Perot Museum to work on an exhibit. Since then, no colds.
I'm going to side with Ron here. I will guarantee you, I love seeing you face to face, but this Zoom call thing, the smell is way, way better. I'm just saying, the smell is way better.
For the future competition, we keep that circulated competition.
Who was the NASCAR driver that was killed at here in Dallas a few years ago? It wasn't Petty, was it?
Earnhardt?
Anyway,
Petty's still alive.
No, who? Earnhardt, yes.
Dale Earnhardt.
Who said, when they were trying to standardize all the cars, right, for NASCAR, so they gave you all these parts. One of the parts they gave you was the gas tank. And so what he and his team would do is they pressurize the gas tank and stretch it, make it a little bit bigger, to hold another quarter gallon of gas, but that makes a difference. And so they got caught. And when they got caught, he shrugged it off and he said, "Oh, if you're not cheating, you're not trying." Now, I understand what he's saying, that you ought to always be pushing the envelope, and sometimes pushing the envelope is called cheating. Sometimes it's not. It's real hard to know. But I do know that robot contests spend a lot of people worrying about people cheating. And I don't know that it's really necessary.
A blower in the hands?
I think that's something more to worry
Here's
about
my
when you have
philosophy.
big dollar prizes.
Here's my philosophy on this thing. I'm agreeing with you there, David, that if you're not cheating, you're not trying, right? You're pushing the edge, right? But in this group of people that we're in, you know, if I'm worried about you cheating, you know, come on, get over it. Because what I believe is, if I'm worried about you cheating, David, it's because I would probably cheat myself. So my worries are exposing my inner character, right? So if you got all these guys going around worried about you cheating or not, guess what that person's probably doing, or probably thinking on doing, right?
And I think that we can trust each other because we're all actually interested in pulling this off, you know?
Yeah.
And if somebody did find a clever way of doing it, they would certainly describe what it was, you know? Well, my robot's just following yours, you know, or whatever. It's kind of hard to define what is actually just pushing the envelope, and when pushing the envelope is somehow seen as cheating. And you know, we talked about with the firefighting contest a few weeks ago. I mean, it's something that happens all the time, and maybe if the first prize is $10,000, it's something people should worry about. But if the first prize is bragging rights in this group, well, cheating won't get you that, you know?
Yeah. Yeah, I think collectively we can look at a thing and going, that was clever, or that was cheating. I think collectively as a group, because of who we are and our interpersonal relationships, I think we can say that, right? Saying that in general or large is probably a very difficult thing to say.
So we're basically suspecting that Chris was cheating.
No, but I guess I was thinking more along the lines, okay, well, here's a good example. Jesse showed us a great video of his car in the parking lot contest. And, you know, they put these big plastic barrels out there you're supposed to avoid. And what he did was he just made his robot robust enough he could just slam into those things and knock them out of the way. Well, that seems to me like that's a pretty good solution. Yeah, you know.
Yeah. I mean, it didn't say anywhere that he had to avoid them, right? It was just implied. But sure. So it's not really a constraint. It's an assumption that some people have, and that's.
But they're not all the same.
Yeah.
Yeah. And
I show you guys some of my.
Like you said, Dave, you know, then if they really wanted you to go around them, and they really didn't want Jesse's thing to go, you know, they just put a brick in one of them, and Jesse would hit it, and that, you know, this whole thing would just go. But I mean, but you know, and I think if you look at our rules are pretty open. I mean, the closest thing I would say to a restriction that we have is the 1 in 6 cans, where you can't purposely what's the word, be aggressive, you know. So, and I think I want to say there's also you can't, for example, color your robot the same color as the cans. And there's a few other things, but you know,
or use big markers that are the same color as the can.
Yeah, but you can, you know, I mean, if you look at the rules, they're pretty wide open to 1,000 different solutions. And I'll tell you what, you know, if you want to look at a classic old-time robot solution to tabletop, the gentleman who a couple of years back came from Vancouver, all he had was a sharp sensor, I think, and he detected all those cans and he lined them up. You know, I mean, he did a fantastic job, and he made it look easy. And he was using the drive-by, I see you on the side, so now I turn to you type algorithm. And so, I mean,
wasn't that me? Did I do that?
Execution, I think everybody in the club would really likes to see a pretty execution, a robot that's well made. You know,
I don't know, Doug, you know, what I really like, I like that kind of sloppy stuff that just happens to work and win, you know? If it's on the hairy edge of just barely working and it survives somehow, that's cool. And then if on top of the thing it takes first place, that's hard to beat that, right? By the hair of its skinny skin teeth.
Success is hard to, it's hard to.
Who cares about repeatable? It's just a one-off.
Yeah, the coup de grace is when it catches on fire at the end.
You know,
Yeah,
and it plays out as it crosses the finish line. That's the best way to go.
I like it. Who was it that used to have the robot that always the wheel would fall off? Was that you, Ron? Somebody had a robot that
No,
you
probably
would
somebody
run,
like Eric Sumner or somebody.
yeah, and you'd be running along, and on one of the wheels would fall off, and
Yeah.
This happened to me.
It's loose not on the wheel.
I
Well,
think
it
this
does-
was in a movie. I think this was in a movie, but I thought it happened in real life, which is kind of spawned the movie. Was some NASCAR event, somebody won the race and they were literally skating on the top of their hood as they,
But you know,
I know it
there
was
are
in a-
things that are
for sure.
instructive
I
to
also think it was a real. I'm like, that's the kind of way I want to win. Just right there at the very end. I've done everything. I've kicked sand in everybody's face. They kicked, but even though I don't have my wheels on the ground, I still managed to win the race by whatever means. Man, I'm with you, Carl. I'm with you. I'm not talking about cheating either. I'm just talking about just gutting it out.
No, this isn't. But to refer back to knocking the plastic barrels out of the way rather than navigating around them, it solves the problem. It's a solution to the problem. It's actually a simpler solution to the problem because it doesn't slow you down. And one of the things I discovered early on when I started running outdoor robots was this definition of what is an obstacle changes, because you don't really need to avoid something if you can climb over it. So you don't need to sense anything you can drive over. By the same token, you need to be able to drive over everything you can't sense. So that's a simpler solution. If you're driving down the road and there's suddenly a pothole, if you can go through that pothole, that's easier than going around it, than having to sense it. So I mean, I find that a perfectly elegant solution.
well, you also missed out on one because I actually was at AVC the year they did the spinning disc top, and so you guys didn't. It was a solution that several people tried, but Jesse was successful at it, so his robot went up the ramp, jumped over the spinning disc, which I believe was must have been at least 4 foot, might have been 6 feet.
It was 6.
And it was spinning fast enough that if you hit it, we've all played with the gyro on the car and put it on a turntable and the car just keeps going straight even though you're spinning underneath it. It was going so fast that I don't think any reasonable car would have been able to keep turning, to keep going straight, even if their gyro was working perfectly. The only way you could actually go through there was to do what he did, which was jump over the top of it. But now think about this. He jumped from his odometry point of view, he left the ground, was in the air, he came down 6 or 7 feet later, bounced around a bit. I'm sure he did. They also had some hay barrel bays that if you weren't careful, you'd run right into those suckers. And he drove around those, and so his system was robust enough to know where he was through all of that. Now you mapped it, right, Jesse?
Yeah, actually, I made it over a discombobulator a couple times, but I didn't actually do it in the competition. That was
Okay.
Minuteman actually that did it during the competition.
Okay. Yeah.
So
But yeah, I mapped the course.
So what were you using for, and sorry if this has already been said and I missed it, what were you using for odometry on your car?
I just have a drive on the main drive gear. I just had 4 magnets and a Hall effect sensor.
Okay.
So it's just reading the drive of the rear wheel.
Okay. So your steering position to some degree of accuracy.
Well, I have the B&O 55 and then the encoder.
Oh, okay. Okay.
So it's just classic dead reckoning, and it's just that I go slow enough that I don't have a lot of slip. That even if you see some of the videos, I was even on a dirt surface. Even on that dirt surface, my encoder over that linked course is plenty good enough to give me good feedback.
How many pulses per inch or per milli, whatever you?
3 inches per pulse.
2 or 3 inches per pulse. Wow. Okay.
So wait a minute. So Jesse, where is the magnets attached? Are they attached on the drive gear?
Yeah.
Or are they, so
They're
on the
on-
drive gear, right,
Yeah,
coming off this?
it's a big plastic gear. It's about 4 inches across.
I think of where that would be.
I'm
So
amazed.
you
I
have
can't
off your
believe
motor
you can
pinion?
find your way.
So you have your motor, you have a pinion, and then you usually have the drive gear.
Yeah, it's on the drive gear.
Okay.
What I would call a spur gear.
So for your heading, you just strictly use the IMU, whatever, the gyro
And-
accelerometer. Okay. So that
And
gives
the,
you a good heading, and then you've got pretty good distance, and that's good enough. Okay.
Yep.
Wow, that's cool.
I've even done good with like 6-inch encoder count, so I actually doubled it the next year. But I've worked with that. It increased my accuracy considerably. But even at 6 or even 12 inches, I was okay. But I was starting to think then about like, okay, if I figure out when was my last pulse, when was my current pulse, I could create like a pseudo distance in between based off the frequency to figure out how far I've traveled. So you might actually be able to get away with a less accurate counter, less pulses if you could do something like that. So as long as your speed's constant, it really shouldn't matter.
Yeah, cool.
Hey, can I share my my project?
Jump in. How you been doing?
So yeah, it's good. First, let me change my filter.
Yeah, you got your blur on.
Let's see.
I couldn't figure out how to turn it off without going out of the call.
Change background. Is this good? Looks
Yeah, you're back.
all right, cool. So yeah, it's been a lot of wiring, but one thing I want to show you guys is this battery. This is what I came up with the solution. So this is the battery like for the car starter, and so there's an adapter that usually it's the adapter that came out with 2 clips last time, right? So I looked up, turns out it's this type of connector. So what I did is I bought this connector, and I put a fuse here, and this end is it's something that you guys recommended one time. So it's
maybe.
AX something, right? I forgot, but anyway, so this will go into, basically I plug in, I get 12 volt, and on this end, so my robot here, I have this wire. Let's see. All right, it's heavy, but basically this is the wire that'll route into my 2 motor drive. My 2 motor drive here, 1 and 2, and so I put a breadboard here. All the wiring of the motor, all these encoders. There's 6 wires, 2 are drive, and 4 are these encoders, right? But now I plug into the breadboard. So the Arduino is up above here. I'm thinking first I'll make sure it's working, and then I'll unplug this. I'll unplug this and put it somewhere that it should go into the Arduino. But yeah, well, one question is this battery solution something that any danger? I mean, I think I put in this fuse, so I'm thinking the fact it's a connector, it shouldn't short itself. But I have a fuse here as well, so hopefully it's safe enough.
Depends on how good your heat shrink is. You know, do you have any exposed wires there in the end?
Oh, I've put heat shrinks here. Yeah, I did. Yeah. I do have heat shrinks.
Yeah. What's the
internal fuse?
what's your amps on the fuse?
I don't know. Actually my son helped me with this, but I got a box of it. But
I think
the
normally
cable
those
looks well
batteries have
constructed.
an internal fuse as well, so that you might, even if that fuse was not to catch a short, I think those battery packs themselves have a fuse on them.
No,
okay.
I think the kind he has is the kind you can weld with because it's for starting cars.
Mhm.
Yeah, because those can easily generate 100 amps, easily.
Yeah.
I can right now it's full power. It works, right? I mean, if I plug it in,
Yeah,
and I have it on full power, the wheels all turn. Seems stable. Seems
So,
good.
so check your fuse, John. 'Cause I
Add
did
fuel in there,
one.
that sounds reasonable.
Check the fuse.
No, I'm saying that the fact that you put a fuse in there, I think makes it safe.
Oh, okay.
Yeah.
Okay.
And it's close to the battery. And probably if you're in the range of 5 to 10 amps, the thing is that if you run the motors at a steady speed, that's probably not going to be as interesting as if you jam the speed full throttle one way, full throttle another way, and all the motors at the same time.
Mm-hmm.
So that's, if you can do that and the fuse doesn't blow, and then if you cross out the power and the fuse blows, then you're good.
Cross out the power.
You don't want to short.
And if you cross out the power and the battery blows and you burn the house down, that's bad.
I'll trust this fuse will protect that ever.
We got Carl's. Everybody has a line. Carl's line is burn everything down, and then okay, got it. I'll let. Okay, so I just keep that in mind next time I ask Carl to do something.
I
Okay,
think the
there's a-
solution is we need an
Harold?
outdoor contest.
This is the thing that I learned at TI years ago is that you test for stress. So, and someone else earlier in this thing said that if you're not breaking the rules or trying to break things, you're not trying. So I say, test till it burns down, then you know where the fail point is.
Well,
Well,
I worked with a tech a long time ago that would take a 5-volt board and start ramping up the voltage just a little bit. His theory was the weak part would smoke first, and then they would that's what needs replacing.
Yep. There you go. See?
Well, your robot is probably pull three or 4 amps. I mean, with everything running, it's not going to draw that much. And and if you've got a 5 amp fuse in there, but what I generally do is I stick in the lowest fuse I think will work, and then I run the robot around and give it a bunch. If the fuse blows, then I put in a little bit bigger one. And,
I tell you, a lot of people don't realize that those battle bots and things, those guys are dealing with motors that are taking 40 and 50 and 100 amps worth of motors and can switch that. Those things are not, they think, well, they're just playing around with those. No, those are not play around with things, man. You get crossways with some of that and you got all kinds of problems, right?
Oh yeah.
So I like David's approach.
And you've seen some of them blow up and burn.
So David's approach is, I mean, in all seriousness, that's a sound approach. And Jean, so for those that don't know, Jean has the same motors and wheels that I have on the hover sim robot that I have. And I can tell you from a little gauge that I run on the robot sometimes that when I slam the motors one end to the other with the pid loops in place, I mean, I see peaks of 6 and 8 amps. I just don't remember if it A, blows the fuse, or B, what size of fuse I use. But since, John, I think you bought the large box of assorted fuses, start with 3 amps, and if you blow a fuse, use a bigger one.
If it keeps blowing,
Cool. Yeah, it's better than I try to short it. I don't want to.
Yeah, don't put a penny in place because that'll burn the house down.
oh yeah.
John, is that a 12-volt battery? That's 12
It's a
volts.
12 volt. Yeah, it's a 12-volt battery.
But what kind of a case does it have, or sheet? Is it? Show us again.
It's a metal case.
Battery.
I mean,
Car starter, right?
sorry.
That's for starting a car, right?
Yes, right. It's a car starter. When I bought it, I thought I would use it on robot, but yeah, this made it feasible. So yeah. So
How much is that? It's probably like $100 battery with $60 at least. Huh?
I think it's 50 from Costco.
Jump.
Yeah, it looked like the
Android
Costco
thing right
model.
there.
Yeah. And that connector looks like an EC5. The blue connector looks like an EC5
It
connector.
is the yes, you're right.
John, does it?
EC, yes, EC5.
Right,
Exactly. Nice. I did the compare a lot of images to figure out this is the EC5.
I can tell you that you have that's a lithium polymer battery, and that's probably a 3S battery. And the problem and also the joy of those batteries is that the internal resistance is so low. You know, you can dump the entire charge in just milliseconds, and that's why you can get 150 amps out of them or whatever. And if I can, how do I share a screen? I have a picture. Do I just push present?
Yeah.
I think so.
Yeah.
Present your entire screen?
Yes. Then you have to click on it.
What am I clicking on? The only choice it gave me was don't allow.
When you say share the screen, a little picture of it comes up and you click on it.
Okay.
The present now.
Down at the bottom of the screen near the right.
Bottom right.
Okay, I'm already past that, and it says, will you allow meet Google.com to see your screen? Window or screen to share, select window or screen.
No.
And I said entire screen.
You've picked the multiple buttons. What you need to do is the thing that's next to it.
It's going.
It's there.
There you go. You got it.
Can you see my robot?
Yeah.
The theme of it.
Okay, so this robot has its batteries in the top, and that's what happened when they burned up. This is robot flambeau, and that robot had to be totally rebuilt. It was in my car when it happened. Unfortunately, my car didn't burn up, but they burned extremely hot. The fire is extremely hot when those batteries catch. You really have to be very carefully tended.
Wow.
How do
So
I
how did
stop it?
How did it catch fire? What happened?
I had noticed prior to wow, this is cool. How do I get out of here?
Stop presenting.
That's it. Stop.
Yeah.
Oh man,
There we go. That was cool. I had noticed that the batteries had swollen a little, and that probably should have been the warning sign for me. And I put them on the charger, and they charged just fine. I will say that the newer design of that same robot, I can remove the batteries and charge them. They're not built in anymore. But they charged just fine, and I took them out. I had them in a leather bag. I had the whole robot in a leather bag that I carried around with. I put it in the back seat of my car. So that I loaded up my car for the next morning. And when I got up the next morning, I went out to the car. There was this fine, sort of a bluish powder covering the entire inside of the car, and I could smell this burn smell. And I went, I looked in the trunk, and I popped the hood, and I looked under the car. I couldn't see anything, and finally I opened that bag. And I think what happened was that it was never able to flame because it was inside this leather bag. So it just basically melted the whole thing. So just actually on one of my helicopters, this one right here, I had a similar problem. Now, on the helicopters, it's not because they can easily eat 150 over 2 or 3 minutes. And I mean, they're just right at the very edge of the most power you can get out of them. But there's a lot of people who've caught their helicopters on fire. But this with the robot was, I've never encountered anything like that before, and I'm much more careful about this now. If I see any spelling at all, I just start.
You say there was some sign that it's not. How did you see it's not?
They swell, they expand, they get bigger.
Yeah.
Bigger. Oh, you mean the bulging?
Yeah.
So in your case, the shell would pop open, or you could see some deflections in it.
Yeah, I see. All right.
but it might be so tight that you won't see it. It might just be slowly failing and you won't see it.
Yeah, there's a few laptops like the Microsoft Surface series and some of the Macs that are out there. You'll see them bulging out pretty bad after a little while. You know, I've seen a lot of those.
The Surface I had, actually they replaced it, but yeah, it was, my son uses it, but at some point it bulged and the screen even got deformed.
There's
And
there's
then I
other
saw
sides too,
Microsoft,
like
it's like a common issue. So they
when you
replaced it.
notice that the battery seems to have a nice even capacity for a long time, and then all of a sudden you charge it to full and you run it for 10 minutes and then it's almost dead, that's a good sign that something's wrong, even if you're not seeing bulging.
The other
And a
thing
lot
is
of the,
heat.
the charging circuits built into battery packs and phones, they actually measure and detect that coming on. But when we do bare packs like David's trying to show, and I'm talking over him, you got to use a little more human intelligence.
This is a 1800 milliamp hour, a 22 volt package, and you really can't see it that well, but you can really feel it, and it has bulged. The sides of it have bulged out, and when you see that, don't take any chances.
You mean like keeping it inside your house and holding it up in front of a camera and squeezing it?
Yeah, exactly right.
He didn't take a screwdriver to it at least. I mean, he didn't try the fire approach.
This is the reason that my outdoor robot uses a nickel metal hydride, because they are screwed into the chassis. I have to take the chassis apart to remove them, and I don't want to have to do that in charge. And the nickel metal hydride doesn't have any of those characteristics. They're actually very friendly. You know, they don't have the current. We can't get the current out of them. But we're talking a robot that wants to draw 5 amps, and I'm going to drive it with a battery that can only supply 20 instead of one that can supply 150.
Well, there's newer technology in LiPo too. There's like the LFIE P04 that they don't have the same risk of fire as what the LiPo does. So it's really where we should be headed in the future from anyone that's making rovers or whatever from a safety standpoint. LiPo is really something that should be going away eventually.
If I was really concerned about safety, especially around kids, I'd probably use AA.
Yeah. That's why I use my tanks.
Well,
you use AA. You know,
sometimes
there was an engineer from TI who was in the group for a while, and he said that if you want to build a portable device that'll work anywhere in the world, that you should power it off AA's, because you can get AA's anywhere in the world.
But isn't it sometimes good to have some hazards as a kid and to get burned? Because I'll tell you, when you get older, I mean, the things get more and more serious. And I think it's better when you're really young to get hurt a bit. You know, when I was 4 or 5, I started soldering.
What you're telling me is, Ron, what you're telling me is, Ron, somewhere around 3 or 4 years old, every kid anywhere on the planet should get a bobby pin and point them at an electric socket. Is that what you're telling me?
Well, or I did wet fingers on the sides of.
I mean, I did it. I just don't. I have a little bit of twitch, but I'm okay mostly. So you know.
You know these little keys that you open up the cans with. When I was, you know, the 2 or 3 or whatever, I put one of those in each of the sockets of an extension cord, and then I put one across.
Sweet.
You know, what doesn't kill you makes you stronger.
Yeah, exactly.
There you go.
It makes you wonder why you do stupid things like that, though. We've all done it.
Yeah, the curious mind. What are those sockets for, right? I think now when I plug in the power, all 3 wheels are rotating, so I've validated all my hardware. So I'm now ready to, I'm going back to my code and trying to figure out what I was doing with those motion control. So
yeah, John, that battery, if it's the one I see here, that'll put out 350 amps.
I'm not gonna short it.
That'll start
Yeah.
your robot.
No. That's what it's rated at. If you probably shorted it, it probably don't go a bunch higher before it blew up.
Yeah.
Mhm.
Well, so initially I thought I would put in a switch. Right now I'm really like plugging this in and unplug it. But I mean I don't know. Because again, I'm glad my son is working together on this. So initially I said put in the switch, and he said, "Well, why don't you unplug it?" But
Put it in the way.
I think it's okay, right? This type of plug is not that difficult to unplug and plug. So,
Try unplugging it when you're chasing it.
I'm sorry.
Unplug it while you're chasing it.
That's what the grab handle is for, right?
Yeah, right. Now
got this
I
thing
have
at the
this
end of your
handle
leg
where you grab it up.
I don't think that's fast enough to worry about that. I think you're safe. Try it with my rover sometimes. We'll see how you do.
How do you empower your rover?
I have a remote control kill, so I can just hit the remote to shut it down. I refuse to run without it for safety reasons.
Yeah, I think, I mean, I'm gonna switch to my software, which is what I wanted to start with. So I think now I'm ready. So hopefully,
yeah,
I'll make it controllable in a few weeks. Yeah, thanks.
I guess I can kind of give you a little update of what I've been working on. I've been writing a whole bunch of Python tests for all basically the fundamental parts of the robot. That's been coming along, so I've got now a Python test suite. And I keep talking about my integrated front sensor, and it's usually attached to the robot, but just now I've actually been doing isolated testing on it, so I can actually hold it up, and this is actually the sensor itself. And it basically runs into one of these little Pimoroni IO expanders, which is an I2C device, with 6 digital pins and 8 analog pins. So basically that's mounted, where is it mounted? It's right there. And so I've got it on the back here, is all the wiring. So this has got 5 sharp infrared, 150 centimeter IR, analog IR detectors, and then it's got 6 little switches that the bumper fits on top, and then this was my latest, which actually has, this is what holds the polycarbonate bumper in front of everything, so that hits that. There's also a camera here, and this whole thing, apart from the camera, this whole thing plugs into the robot with 5 wires, which is pretty well. I'm getting spurious digital pin actuations now, which I'm assuming probably has something to do with the 5 IR devices, which I think do a lot of spiking. And but apart from that,
do you use like a pull up or pull down on those IO channels?
Yeah, I'm using a pull up, but I think I might go ahead and actually put in some real physical resistors. I'm not sure. I think that's actually what's happening. I think is that the pull up isn't working very well because it tends to trigger.
Probably too weak.
Yeah, that's what I think. So I'm gonna probably put some actual. It's only 3. There's only 3 of them, so I think I'll just put 3. I think 10K resistors probably, and that way I can be more guaranteed that the actual pull up is working, because that's, I think, exactly what's happening, Jesse. Is the pull up isn't actually enough, especially with all the extra wires and everything around here.
Yeah, watch how you route them too. Try to keep them separate from one another, from the analog and the digital channels.
Well, unfortunately, as you can see on the back there, it's basically just
yeah, it's a rat's nest.
Options, but yeah, it's.
And also, Murray, you can twist them with a ground lead.
Yeah,
that may help as well. So, are you familiar with twisted pair?
Mm-hmm.
So the idea is what you take is individual strands of wire, and like usually when we do it in the office, or when we used to do it back at TI, we would just take 3 or 4 wires and put them in a vise at one end, and put the other end in the power drill, and then just spin it around until it was a nice so many turns per inch.
Yeah.
And what that does is it provides a return path for the EM fields. so that it helps keep the signals contained within the, between the, it closes the loop between the signal wire and the ground wire, and it helps keep the signals contained, and it helps prevent stuff from getting in. So it's a good way, if you're gonna do loose wires like we always do, you're always much better off to make sure you have a ground wire in the mix and twist it if you can.
So like for example, the longest one I've got is everything's on this side, and I've got this one wire that comes across over here to the far infrared sensor.
Yeah.
But that's not, you're basically saying I should just twist that wire?
The whole wire. So like I would want to look at that and see like 3 or 4 twists per inch at least, something like that.
All right.
Now, when you do that, it's going to shorten your wire. You're going to have to get longer cables, but
Yeah. But that's the only one. I mean, I wouldn't have to do that on the switches because those are just basically. I mean, I'm probably going to need pull-up resistors on the switches, but the infrared sensors are probably where I need to twist.
The longer the run, the more important it's going, the more of a difference it's going to make for you.
But
Okay,
even
well, there's
digital
one
pins,
long,
you
so I
can
think I
pick
just
up
replaced that
noise.
one.
Even on digital pins, you can pick up noise. That could still be a problem even there. Like if you have a motor turning on and off, it's going to generate an EMF field, and basically that wire acts like a generator, and it'll build enough voltage, which is what he's talking about for the cancellation. So even digital pins can.
Well, there's something else going on. That's actually why I pulled this off the robot, because I'm actually running it off the separate Pi that I'm using outside my, like Jesse, you haven't seen my robot, but I think I can, that's, there, can you see that?
Yeah.
So normally that fits on the front of the robot with just 2 4 millimeter screws. And then I've just taken it off the robot so that basically I can do testing in isolation without the motors and everything else around there. And because I was getting this spurious signal in it, it turns out I think the spurious signals on the digital pin are entirely because the pull-ups aren't high enough. That's actually what I just did this morning. And then the other thing I think I reported already is that I had spent, I don't know how many hours trying to get this BNO 85 to work. And I've had a lot more luck with the 55, and the 85, for some reason, it would just blow out stack traces to the screen as I was running it, even when I was running the Adafruit test. And what it does is they've set up a whole bunch of different what they call reports. And in order to get the thing to run, you have to have about 5 or 6 reports running. And just every once in a while, just every few seconds, it would blow out a report. And so I was just running that in a try-catch loop and just ignoring it. But there's just so much noise on it. And I just couldn't get it to be stable. Whereas with the 055, once it calibrated, I know this is a really perverse way of looking at this, but and we talked about this earlier, but my approach to this whole thing is kind of perverse, that I'm trying to see if I can run a 55 indoors with a magnetometer. I know. But, and it's the 1966 Kiwi house. It's all wood floors. There's not a lot of stuff in here. And so far, if I've got both an ICM 20948 and the BNO55, I've got it so that when they both give me the same number, and they don't that often, but when they do, so far my tests have been that it's relatively reliable. So we'll see. I know you're all like nuts, but
What kind of impact would you have from, let's say, alternating current in wires? How does that impact your magnetic field? I mean, is that one of the things that you'd find in a house that's that would be variable, or
well,
just things?
I mean, there's all sorts of things in a house, of course, and I'm not a fool to think that's not happening. I guess what I was trying to do, and I'm still experimenting with this, is that there's, if I can find it, oh, here it is. So this is my my nylon and entirely plastic top end. So that is a ICM 20948, a little breakout garden thing from Emeroni. And then that's my BNO 55 on the top. And this fits 25 centimeters above my robot. And like I said, these are very, very different IMUs. And when they tend to agree, it tends to be relatively pretty good. I'm happy with the results. it's about, like, as you guys have worked with the BNO55 know, they go in and out of calibration. But when it is calibrated and it agrees with the ICM 20948, I've been getting pretty good results against all of your skepticism. I mean, I understand it's not supposed to work indoors, but when they're working, it works. And that's so far my thesis anyway. And I'm going to keep going at that until I'm proven wrong.
Awesome. We're rooting for you, Murray.
Well, and the only other thing, like I said, it's like I was really disappointed that I couldn't get the BNO 85 to work as well as the 55. I thought it was supposed to be an improved model with this Hillman library and all that, and I just couldn't get it to run. It just seems, and I'm, I've got a whole box of IMUs. I mean, God, I think I've got. So here's the FX OS 8700, FX AS 21. There's another one. And then I've got another one here. I mean, I've got a whole box of IMUs. And what I've been trying to do is figure out that I can find two IMUs that perform really differently. And then if I can do a fusion of the two of them, that would give me some confidence that indoors they can be relied upon when they fuse properly. But in any case, that's about it from me. We're heading up the east coast of New Zealand in a couple days, and we're going to, if you look on Google Maps, you can look at a place called Talaga Bay. There's nothing there. It's just a big empty bay. You can walk about half a kilometer out into the water. It's where Captain Cook, I think, first landed within a few kilometers there. So we're just basically going out to the middle of nowhere. So looking for, it'll probably rain though, that's what I guess.
Captain Cook went everywhere.
Yeah. Sure did.
Planted cook pines on Hawaii.
Yeah, well, there's a lot of people who are not so happy with him nowadays. So the statues are being torn down or effaced.
Ooh.
Yeah.
What was he, a slave trader or something?
No, he just he brought white people to a place that didn't have white people. I think that's really what it came down to.
Oh.
If it wasn't for him, New Zealand would be Polynesian.
Yeah. Oh, yeah.
Yeah.
Maori,
Maybe people are angry about that. I don't know. But in any case, that's it from my end of the world. I'm going to continue to. Oh, there's my cat.
That's for run simulation.
Send me some digital photographs. I need a front, top, and right side, and we'll map the cat into the simulation.
Give him a metallic skin so he reflects all light.
Yeah, the one thing about him is that he's not like other cats in that he has no tail. That's his little black tail. So he doesn't have any tail to run over like other cats.
Is he a Manx or is he just losing?
No, he's a Japanese bobtail.
Oh, Japanese.
Oh,
Okay.
different colors, right?
He's greasy. Doesn't take care of himself.
Oh boy.
Yeah, that's what happens to the older cats,
Yeah, I think to all of us maybe.
We get greasy.
Speaking of that, Ray, what you got going on?
Can I ask a quick question about this wire twisting before?
Sure.
So, what about, I have 4 wires, 5 volt, 5 volt and ground, and then 2 encoder. Do I twist them together or
Twist them all.
twist into one bundle?
One bundle, just twist them all together. I mean, what'll happen is that if you look at how super high signals are done, like if you look at the routing from these high definition, high bandwidth camera sensors to the router to the processor boards, I mean, they will have not only a twisted, they'll actually have like 28 coaxes. They'll have 28 coaxes. They're like tiny little coaxes, but they do that so that they have a low impedance and high frequency. And what you're doing, I mean, we're not worried about video signals. We're just having these I2C buses, and I mean, they have fast transitions, relatively speaking, but they're not video signal kind of bandwidth, and they're not designed for that kind of stuff. So you can get by with just twisted pair, I think, and it should at least improve things. As long as because whenever you twist it, you add capacitance, distributed capacitance to the connection. And as long as the driver chips at each end can overcome the capacitance, so there's a little bit of a trade-off there.
I should take any cable. I mean, it sounds like motor cable, two wire. I should twist it. Then a bunch of signals I twisted. I mean, it's not bad to twist the wires together, right?
Yeah. So the thing is that your ground and your power, those are going to be like so-called low impedance, right? Because they're not a signal wire. They're meant to carry a lot of power, so they should be low impedance. And when you twist a signal wire with either one of those, then it gives any loop with the wire. Like if you have a loop and you have a magnetic field through the loop, it'll induce a current, right? Or that's just how magnets work, right? You have a loop of wire and a current, and it makes the magnetic field. And that works whether you have a magnetic field crossing through the loop or whether the current's going through a loop and it's generating a magnetic field, so it couples from one pair of wires to another. So by twisting it, what it helps do is keep the magnetic fields contained,
or canceled,
so that whether the magnetic fields are trying to escape from the twisted pair or get into the twisted pair, it helps prevent that from happening. The twisted pair helps minimize that.
Oh, Carl, just to clarify, twisting the wires doesn't create capacitance directly. It creates inductance, and it's the inductance that creates the capacitance.
No, he's talking.
No?
No, you're reducing the effective cross-section and balancing it.
Okay.
So,
but it's not creating inductance then.
No, what you're doing is okay, if you have the two wires, then a magnetic field going through them, you've got a big loop, right? But if you take this and make one twist in it, then the field will cancel.
Yeah, makes sense. Since
capacitance, you're making it so that stray magnetic fields that are alternating aren't creating a voltage in the wire.
So as far as capacitance go, I do this in electronics for programmers, and I make a capacitor in the talk, which is basically I get a sheet of paper and a couple of pieces of aluminum tape and show, hey, I got capacitance, and I cut it in half, and it cuts the capacitance in half. So effectively, if you got two wires running straight down the way, you have a capacitor there. It's just not a very good capacitor. And when you start doing the twist, like everybody's been talking about, it now eliminates that or crosses that out to make.
No. Well, you're on the right track. When you do the twisted pair, it brings the wires closer together, which does what? It increases
you're doing two things. One is that putting them closer together makes the area of your coils smaller, and the fact that it's twisted means that if the field is alternating next to each other, they'll cancel.
Magnetic fields cancel.
The magnetic field.
If the magnetic field is across the big area, then the twisted pair on average cancel.
Right, it'll cancel it out.
Yeah, but what's funny is when you get down to the really, really deep electronics, every resistor has a little bit of inductance and a little bit of capacitance just by the very nature of its thing. It just, for the most part, we don't care about that at whatever level we're working at, right? Every inductor has a little bit of a resistance. Every capacitor has, all that sorts of things, right? They all have a little bit of all the stuff, but for the most part, we don't care about that in real world usage.
Right.
And every wire, every conductive thing has all the properties.
Yeah.
Has all those properties.
Yeah, you take that to extremes, and there's no such thing as digital because it's all analog. And you take that to extremes, there's no such thing as analog because it's all quantum. So whatever.
And many of the people I've met have a bit of resistance and a bit of capacitance.
I don't know anybody who has any kind of capacitance, whatever.
It's good to know the good practice. I can see a lot of wires I can twist. So I'll do it.
I've seen a lot of blown fuses from people too.
Twist your signal with the ground and see if that doesn't start to clean things up for you.
I don't know the motors that you're using too. Carl, you might check. I don't know, Kenny, either one. But you should have a capacitor to the case on both sides and a capacitor between the two leads to minimize noise. You probably have them built into the board that's on the back.
Encoder.
But you might not.
I haven't looked at that. And those motor cables, they're ribbon anyhow, so it's not like you can twist them. But at least they're ribbon, so they're controlled, right? So-called controlled leads. They're at least
No,
constant.
I don't mean that. I'm talking about from your terminals on your motor.
Yeah.
Okay, you should have a capacitor from each terminal to the case and one between the two terminals.
Yeah.
All right, and like I said, on your little disc that they have on the back of the motor, they may have that already. So but you might want to check, because if you don't, you'll have more noise.
And what do those do, right? Those capacitors couple high frequency signals, right?
So basically what you're doing is you're trying to knock down the high voltages, high frequency, high voltages.
They will send high frequency transients to ground, meaning the case.
Exactly.
That's what they do.
Yeah.
And that's because the motor has a winding, so it's pretty inductive. And when the brushes go by, you're breaking that circuit, and it's generating a high voltage spike.
Yeah. And that's why I say that can really reduce the noise on your motor if you have those capacitors. But like I say, since you're buying a kit, they may already be there as part of your encoder circuit.
Yeah,
but you might want to
be careful to not overdo it on the capacitors, or you burn up your driver.
Right. Oh yeah.
So
basically
what? Were you trying to tell me if a little bit is good, a lot of it may not be better? Is that what you're trying to tell me there?
Yeah, yeah.
You specifically want a little one. A low value, I should say.
Yeah, otherwise your motor is going to keep running when you don't want it to run.
Well, you're just trying to knock off those high frequency spikes. That's all you're trying to do. A good value is something like 0.001.
Yeah, and a ceramic, because certain capacitors do better high frequencies than others.
Yeah. I really need to get me an O-scope so I can demonstrate some of this stuff on my Twitch channel about doing all this stuff, because I can visualize it. But if you never visualize this stuff and actually did some experiments to see it knocking that thing off, flat lining or making it kind of flat as you're going, limiting those things, I mean, I guess some people will get it. I just can't. I need to visualize the thing at least.
You need to see it. As soon as they deliver, Harold, you'll be there.
I know as soon as they deliver, maybe in March from the last
Fingers
thing.
crossed.
I don't know. I think pawn shops are a great place to find oscilloscopes nowadays. I got a high quality Japanese Iwatsu, like one of their better ones, for like $200. And
I haven't looked at that. I should go look at that.
Yeah, but a lot of people buy, there's a lot of people buy oscilloscopes and then don't know what to do with them.
Yeah.
So is it a
I can't tell you I know what to do with them. I know how to do a couple things, but really what to do with them, I'm not really sure. So, that sort of thing.
But they look really cool.
But they look really cool.
Yeah.
Yeah, I tell you one thing though, because I've had old Tektronix and old HPs and all sorts of oscilloscopes. But I think I got a Rheingold now. That's the way to go. If you get one of these new scopes, they're only about this big. They weigh about 2 pounds. They got a whole bunch of additional features in them. They automatically have storage. They're just way better than an old-fashioned, something. That's okay. I had that. I finally got rid of mine. So, but now
I've got one of those in the closet.
Yeah.
And then I've got one of the nice small new ones like Doug is talking about.
Yeah, I keep thinking about getting a small digital one, but now that I've got this, I can't really justify it.
Yeah. in fact, the new ones have an auto button on them, and it'll automatically figure out what scale to use and how to sync it and everything else.
Take all the work out of it.
Yep.
Little Renko like this.
Yep.
Oh, yeah.
And 4 channels. And I think it was about $200, maybe 250. Can't remember, but it was. You know, I fought it for years and years and years because I had a Tektronix, and very similar to one you had, Murray. And you know, it worked every time. I don't use it very often, and every time I used it, it worked. But just the reduction in desk space was just it's incredible, and all the features are just for this is definitely, if it wasn't on your Christmas list, it should have been.
Well, just think about how deep large screen TVs used to be before they went to flat panel. They used to take up a huge portion of a room.
Oh yeah.
Oh yeah, we had one here in the house, and it was, you know, huge. It was a console.
Yeah, like 4 feet deep.
Yeah.
Okay, well, I think we're running on the clock here, but and Ray and John, I'm not sure. I think you might be the last 2 guys. So do you have any updates, Ray?
Yeah, I've been working on the plasma table. I had these were, you can see them here. They're NEMA 23s with an encoder on the back, and it had a lead screw and a recirculating ball slide on it. And they're, I don't know, about 2 feet. And I was gonna try to use these to drive the plasma table and attach them with the least amount of machining. And you know, I've got these other plates that I was gonna cut off. I was gonna cut this off here, and that was actually gonna hold the router for another project. I think I can just use the L shape here that'll cut off from that as a brace, because I've got to make sure that the 2 pieces, the 2 slides, don't move with each other with respect to each other. An angle plate, I think, will do that. But just trying to use what I have and not buy a bunch of extra parts to do it. And, so anyway, that's what I've been up to. All that, I don't know if you can see it or not, but all that junk on I have a table down there, and there's, I had some of the 45 pieces from Tanner's. Wow. Similar to 2020, but a lot bigger. And ball slide, or not ball slides. Gotta figure out what they call them now. Oh, recirculating ball screws and other slides from other things, and I just wanted to try to use it all to make a small plasma table. And I don't know if you remember, Ron, I bought all that stuff.
Yeah, thank you. Your money was much appreciated.
Yeah,
especially now that I'm being starved out by all my people that I contract with.
You're being starved out? What do you mean?
Well, I mean, put it this way: the volume in sales for me has been cut by 90% in the stuff that I've been doing. So anyway, this year, but it's allowed me to do other things. So
that's good. Anyway, that's pretty much the only thing I've been working on, trying to get all that stuff together. And make a small plasma table.
I just had one thing to add to Murray with his greasy cat. I did type in the notes there, Murray. Lanolin, which you probably have a prevalence of since you're sheep country, or goop, anything like that is great for cutting the heavy oils on a cat. If the cat will accept the bath, if you do goop or lanolin first and then rinse it, and then do Dawn, like a detergent, and rinse it, keep it out of the cat's eyes, that cat will be gorgeous, like a show cat.
Well, he actually used to be a show cat before I got him. He's a retired stud.
Oh, okay.
Yeah.
Well, that's the trick with cats, because if you use detergent, you'll never cut their natural wax, whatever stuff, but lanolin will cut it. But then you cut that with like Dawn. But that's the end of that story. I'd be happy to talk cat washing.
He's actually a cat that can be washed. He screams. I actually have to phone my neighbors so that they won't phone the police on me because he yells so much because he thinks he's dying.
Oh,
but he's not. He doesn't actually scratch the hell out of me. But the problem is that as soon as he's had a bath, he's like a typical dog because he actually is very dog-like. He'll just go out and he'll just roll in the dirt. So
Yeah. Okay.
Find something stinky to roll in.
Yeah, he was an indoor cat. The very first time he actually got out on grass was after I bought him. He'd never been outdoors. He didn't know what grass was. So now making up for lost time. So.
Pretty wild.
Yeah, he's really wild now. Well, he doesn't look very wild right now. He's sacked out behind me, but yeah.
I like Harold's image there with the Harold's picture with the electrical outlet. What happened there?
I think he's in his garage. I think that's the garage door opener outlet.
Yeah, now you're watching
the garage ceiling.
So now what you guys are actually seeing is I had this laid down. I'm now in the garage, and you're seeing my handiwork, but I need to replace that outlet, by the way. I just hadn't got around to doing that because when I moved in this house, it was all studs. So I went in and I put insulation in all the walls, epoxy the floor, drywall the ceiling, and ran all kinds of electrical in here. So I've got the plug you were just seeing there is actually switched. So I've got five of those sorts of lights in the garage that are on a switch. So I've got light all over my garage. And then I've got another plug on the other side of the light next to each one of those lights that's a couple of circuits so I can plug in anything, that is not switched. So if I need plugs anywhere in my garage, if I'm any more than about 4 feet from 5 feet from a plug, and that's vertical distance probably, I wanted plugs everywhere. So I didn't have to worry about running extension cords all over the place. So that's kind of that's one of the lights ones you're seeing right there.
Yep. I bet your compass will work great in there.
Oh yeah, your compass will be awesome in here. Especially when I start turning the lights on and off.
That's cool.
Oh, I forgot. I got two more lights that power the dishwasher area and a storage room back here that are also on that switch as well.
I was going to ask if it's kind of common in Texas, but it's Harold, and I'm guessing probably not.
No, it's not. I mean, I don't know who builds these things that I get up. Now, my house was built in 1933, so the fact that I have very few plugs in places is not uncommon. But I've got brand new houses and stuff, and I'm like, you can never find a plug in one of these rooms or one of these things. All the time my friends are asking me, hey, can I get this? Can I get that? And, I helped, it was almost 20 years ago now, I helped run a bunch of not electrical, but low voltage stuff when you wanted to run hard wire in everybody's rooms. And people were looking at me like, why would you want, 2 Ethernets and a fiber connection in every room in your house? Why would you want that? I'm like, well, duh. Who doesn't want that? So man, it's just me.
Just you.
Even with wireless that you have today, let's face it, wireless is cool and all, but when you were like, I've got Twitch streaming going on and a few other things. If you've got very much of that going on, wireless is a hub situation, not a switch situation. So it's real easy for one device or two devices to suck up all the wireless stuff you got going on, and then the wireless thing you want to run, you can't run it. I mean, maybe I'm just being old and crotchety. I don't know, but
and it's easy to jam.
Yeah.
Well, I've got to head out of here, guys.
All right, we'll see you.
Holidays.
Take care.
Yeah, it's about that time.
Yeah, I won't see you for a few weeks, so Good holiday.
Well, we'll catch you on the other side. We'll catch you next year then.
Yep. Everybody, everybody have a Merry Christmas, Happy Holidays, Festivus, Kwanzaa, whatever the thing is you need to celebrate that makes you feel great this season. So
That's
yes.
good, I think, yeah. That's
Outstanding.
Bye.
We'll see you, Murray.
Bye.
Is there anyone else before, like, John, did we miss you or you covered?
Only thing I want to make a comment is James before he gets off. Yeah, I saw the cat. There are different types of cats, and there was one in the Maker magazine, I guess a year back or two, whatever year, that they actually laser cut out wood. So yeah, there's different variations out there. But I tend to like one of the 3D printer I have, so hence I gravitate more to 3D print.
yeah. Yeah, I was thinking about printing the last
And
one.
the baby ones are nice too. So yeah.
Yeah.
I posted there. So yeah.
I looked all over for it. I couldn't, I was like, I thought it came from MIT, and
Oh yeah, there are variations of it.
Yeah.
So.
Okay. Well, thank you.
So with that,
Bye,
I guess
guys.
I'm going to call it a good night too.
All right.
Okay.
Sounds good.
Y'all
We all have
take
a great Christmas and we'll see you when we see you next.
Yeah.
Merry Christmas, everybody.
Take care.
Happy New Year.
Take care. Bye.
Bye.
Hey guys.